Hello and welcome to this live stream. So first of all, I would just want to check whether I am audible. Just a few messages on the chat section will let me know that. That's great. That's great. Thank you so much. So a very warm welcome to this first Hack Live session. So one of its kind. So we're trying it for the first time, wherein we will be solving a live hackathon that just went live on Data Hack, and we'll be solving the problem statement from start to finish within these two streams. The first of which will be is happening today, and the second stream we will do tomorrow at the same time, which is 12 noon. All right, so let me just share my screen and get this started. All right, guys, can you see my screen now? Perfect, perfect. All right, so before we start our discussion and where are we, what are we going to discuss during these two live streams, and what is the problem statement, I want to quickly introduce the two panelists. So one of them is Nikhil Kumar Mishra, who has just joined us as a data scientist this month, and he has been one of our top hackers at the Data Hack platform, and has been in top 3 in more than 25 hackathons. So he comes in with a vast experience of doing really well in hackathons across platforms, starting from Kaggle, Analytics Vidya, Zindi, and so on. He comes with a vast team experience as well. He has teamed up with a lot of other top hackers to participate in these hackathons, and he has himself, went through the grind during his student days to, starting as a beginner to participate in these hackathons and doing well, and then improving and improving. And today he's one of the top hackers at Analytics Vidya and even at other platforms. So welcome, Nikhil. And then something about me. My name is Ankit Chaudhary, and if you would have participated in any of the hackathons, you must have seen me on the discussion forum or the Slack channel, as I lead the hackathons category at Analytics Vidya. And I am also a senior data scientist with Analytics Vidya. I've also contributed to a lot of online courses that you can check out at courses.analyticsvidya.com. And my basic responsibilities are to organize these hackathons for the community, discuss it with our clients, what is going to happen next month, what are the hackathons that are going to be happening next month, design the problem statement, look at the data set, create some benchmarks beforehand before a hackathon goes live. And I get to, so the best part of my job, I get to look at the top solutions from these hackers. Whenever we organize a hackathons, I get to review their code. I get to see how the hackers approach a particular problem and ultimately end up at the top of the leaderboard. All right. So without any further ado, I would want to know something about you. Before starting this session, I want to get in and understand who is my audience. So I would just like to launch a couple of polls. So please answer those polls so that I have a good idea of uh, uh, what is your experience and with respect to hackathons and with respect to data science. And here you go. So this is the first poll. This is regarding hackathons. Please answer the poll. Thank you so much for the response on the first poll. I see that a lot of a lot of the members, a lot of the joinees, it is their first hackathon experience, and I'm really excited for you guys to, start on your journey for the first time with this hackathon. And for those who have already worked on hackathons, for them also there is something in both the live streams. So in both the live streams, we will introduce the entire process a hacker goes through while solving a particular problem statement on the hackathon platform, and ultimately produce a solution that lands on the top of the leaderboard. So let me launch another poll. All right. So request to share the poll results. You can see the poll results. A lot of the joinees today that we have are students. A fair good proportion are professionals who want to switch to data science, and hackathons actually are a very good platform to, uh, enhance your resume, add some projects, add some real life projects on your resume that you can use to get recruiters to look at your GitHub profile and get to look at your LinkedIn profile and ultimately reach out to you with respect to the job opportunities that are available in data science. So yeah, so those are the results for the second poll. All right, so let's get started. So if you're wondering what is this platform that I've opened on the screen, if you can see the screen, I have opened something called Google Collaboratory. Okay, so just to give a brief overview of what is Google Colab and Collaboratory, so you can access this tool at collab.research.google.com, and here you can launch a new node. So here, this is a platform where you can actually write your Python code. So if you have used Jupyter notebooks in Anaconda, this is very similar to that. But the good part is it has reduced a very important hurdle for anyone who wants to start with data science. So earlier you need to have, let's say you need to have some kind of configuration in your laptop, minimum this much gigs of RAM, minimum this much processor. You would need a GPU if you want to do deep learning, and then you would need to set up everything. You might also face some bugs and in Windows, depending on the platform, let's say you're using Windows, Linux, or Mac. But this in here does not need any of that. Your laptop should be capable of launching a browser, and in a browser window, you can just go to this website called collab.research.google.com. Google, our savior and our hero, has launched this particular, and it has been some time since it was launched, and you can easily create new notebooks here. You can write your Python code here. You can import your data set and write your Python code, visualize it, create your submission, and do end-to-end things that are required to participate and do well in a hackathon. So just to give you a brief overview, you can just click on new notebook to start a notebook. And once you have started the notebook, it's loading right now. Yes. So you'll get this untitled.ipynb, and here you can just, start writing your code, import your libraries, get started with uploading your data set, and then work on it. All right. So essentially, what you need to participate in a hackathon with respect to machine is nothing but a laptop that can run a browser. And in that browser, you are able to access this. You need a Google account to access this. You need a Google account to access collab.research.google.com. And here you can just import your data sets, read them, work on them, create your predictions, download your file, and finally make a submission at the platform to see the scores. Okay, so this is the brief idea of the tool that we're going to use here. And this is what we call as Google Colab. So now coming to the steps to actually participate in a hackathon. So you must be aware that there are other ML competition platforms as well. For example, Kaggle, right? So Analytics Vidya has its own platform for those who have not participated in a hackathon at DataHack. It's called, the hackathon platform is called DataHack. And this is the problem statement that we're going to work with today is linked right here. All right. So, so those of you who are here have already registered for this hackathon and would be able to see the problem statement now. As this just went live and it ends in 1 day, 11 hours. So this is a 2-day hackathon, 1.5-day hackathon, and you can register from here. So for a new hackathon, you would always have to register. And once you have registered there, you can then accept the terms and conditions. And then once you have accepted the terms and conditions, then you can go on to participate in this hackathon. So let me just open this. I think this account is not there. So let me try with my other account. Yes. So now that you have already registered for this hackathon, you would see a problem statement, a solution checker, my submissions, and the leaderboard. Can you guys confirm if you can see that? Can you see these tabs on your? Yes, that's great. That's awesome. All right. So once you have registered for a hackathon and the hackathon goes live. So for example, this hackathon was listed on our platform 1 week ago and it went live just today. Only after it goes live, you can access the problem statement, the data sets, the solution checker, and everything that you need to participate in a hackathon. Okay. So now this is a guided hackathon that we are working with, and this is the problem statement. You have a solution checker, my submissions, leaderboard, and a discuss tab to discuss various topics that you have regarding the hackathon. So if you have anything related to the problem statement, any doubts related to problem statement or the data set, you can actually go to the discuss tab and check it out there. So in here, under most circumstances, we conduct a machine learning hackathon where there's a problem statement or a business problem on the basis of which you have to understand what is the ask. Then you have to make some predictions and submit those predictions in order to check your score. And ultimately, the final ranking is based on the score generated by your predictions. So that's the overall construct of a hackathon. So in this particular case, we are dealing with a problem statement related to marketing campaigns. So marketing campaigns is done by every organization. We Analytics Vidya do our marketing campaigns for our courses and various products that we have over the email and various other platforms. Similarly, banks also do a lot of marketing campaigns to cross sell their products. So for example, if you already have a personal loan, if you already have a vehicle loan, I would want to sell another product to you and see if I can generate more revenue from my existing customers. So again, marketing campaigns can also be reached out to new customers as well. So for example, we have collected some leads on the basis of some earlier events, and those leads are basically phone numbers, email IDs. So maybe I can reach out to them via an email campaign, or maybe I can reach out to them via a telephone campaign. So all these campaigns, the ultimate objective is to convert the customer to get to buy your particular product. So marketing campaigns are characterized by focusing on the customer needs and their overall satisfaction. So whether it will be a successful campaign or not, it depends on various aspects and purpose. So for example, segment of the population, distribution channel to reach the customer, whether you're reaching out to, via telephones, radios, TV, social media. Segment of the population means whether you are reaching out to customers in a particular region, whether you're reaching out to young customers, whether you're reaching out to, let's say you have a retirement product, so you would reach out to a different set of customers. So that's if you're reaching out to students, then it will be a different product and it will be a different kind of campaign, right? So then the third part is, what is your promotional strategy? Okay, so what is it that you're selling? What is the script that your telecallers are using? So that's your promotional strategy. So now you are in the shoes of the lead in the marketing analytics team for a banking institution. And there has been a revenue decline for the bank. and they would like to know what actions to take. So after investigation, it was found that the root cause is that their clients are not depositing as frequently as before. Okay, so basically, how does a bank make money? So with the deposits that the bank gets, it lends a proportion of it to other people, other customers as loans. And on those loans, they earn their interest. And that is majorly how a retail bank makes its money. Okay, so if those deposits are lower, it can lend less money, and that can lead to drop in revenues. Okay, so now for this particular bank, there has been a revenue decline. And after some data analysis, it was observed that the root cause is the clients are not depositing as much as was expected in this quarter, and it's dropping somehow. So term deposits. So what are term deposits? You must have, many of you must have heard of fixed deposits, right? So you have your savings account in a bank. That is very liquid. You can withdraw it anytime without losing anything. But on this savings account, you get a very low interest rate. Like for the some of the top banks, if I would say, like HDFC and ICICI, you get an interest rate of around 3 to 3.5%. But if you talk about term deposits, there are two types of term deposits. One is fixed deposits. The second one is recurring deposits. For both of them, you get a much higher return on your deposits, but you cannot break it without paying a penalty. So this gives bank a lot more. So they do have to pay a higher rate of interest to the customers, but they have some amount for a longer time that they can use to sustain, that they can use to lend to more people and hence generate more revenue. Now, the ask is the overall idea is the banks also hold better chance to persuade these term deposit clients into buying other products such as funds or insurance to further increase their revenue. So once if they are able to sell this product, which is term deposit, that constrains the customer to set up a time. For example, I am doing a fixed deposit for 3 years, so I cannot withdraw that money within 3 years without paying a penalty. Okay, so but I will get a higher rate of interest on that particular deposit, and the bank gets to keep my money for a longer time, and hence it can use to lend it to other customers in form of loans. So now you are provided a data set containing details of marketing campaigns done via phone with various details for customers such as demographics, what are the last campaign details, when was the customer reached out the last time, and you need to help the bank to predict accurately whether the customer after this campaign or after this call will subscribe to the focus product of the campaign, which is term deposit after this campaign. So what we want to see is if we can use, if this particular campaign is effective or not for a particular customer. If I identify that this customer is more likely to get a term deposit, and I can extract those customers beforehand, what is my benefit? What is my benefit? Can someone say in the chat section? If I'm able to accurately identify more customers, yes, you can sell more. How? Because let's say you have just 100 people in your customer service department. Okay, from those 100 people, some of them are top performers. So maybe for the customers who are more likely to convert, you can then plan and assign your top performers from your customer, from your sales team or your telecalling team. You can assign the top 20% of these telecalling team to call these customers, and that overall increases the revenue as such because their conversion rate is higher, and I'm able to allocate my resources in much better way. There are various other benefits as well, because once you have this criteria wherein you can say that these are the customers who are most likely to get my term deposit based on this method, then I can accordingly maybe reach out to them in different ways. The intensity of the call can change, the messaging of the call can change. Okay, so all these things can be figured out from something like this, wherein I'm able to predict whether a customer beforehand, whether a customer will be able to will subscribe to a particular product or not. Right. So now every hackathon will have this problem statement. And this is often undermined. Most of the hackers, what they do is, without looking at the problem statement, they just download the data and start working on it. So that's not a very good idea. Why? Because if you do not understand the problem statement well, you will not be able to connect the dots when you're exploring the data. Okay. And also, outside hackathons, if you're working on a real data science problem definition becomes the most important and the most uh, time-taking process for any data science project. So if you have defined your problem well, if you've spent your time with talking to various domain experts, talking to various people from various departments, only then you are able to define a crisp problem statement for your data scientist team to tackle. So that is why understanding and reading the problem statement is very important, and you should always first do this. So then always in a hackathon, you'll see a data description. Okay, so what's a data description? Data description describes what is the data set, because ultimately this is a data science competition. It's not an open-ended case study where you just have to, put down some ideas. Here you have your data, and on the basis of that data, you have to then submit your predictions. So what is this data set? So in your data, you will have 3 files usually. So you will have, let's say, a train set, a test set, and then a sample submission. So your train set will have some input variables. For example, the ID, the customer age, the job type, the type of job of the customer, marital status of the customer, educational status of the customer, default, balance, housing loan, personal loan, whether the customer has both these loans or not, communication type, day of month, last contact duration. So all these are input features. Now, what is that we have to predict? Term deposit subscribe. All right. So term deposit subscribe. So what does this mean? Whether the customer that we're reaching out to subscribe to term deposit after this campaign. So then we will call this campaign a successful campaign. So for every row, we are reaching out to a customer, and we have some details of the customer and some details of how the previous campaigns went with the customer. Now, on the basis of that, we have to make a prediction, and it's a binary classification. Binary means 2. Classification means you have to predict whether the particular customer belongs to class 0 or class 1. What is class 1? Class 1 is if the customer did subscribe for a term deposit, then we call it class 1. Otherwise, we call it class 0. Second, we have the test set. Now, what is the test set? On the basis of this, on the basis of all the input variables that you see, you have to use this trained data to make your predictions for the test set. So these are the set of calls or the set of customers for which the prediction needs to be done regarding the subscription status of the customer. So for these set of customers, these are a different set of customers from your trained data. And for these, you have to make prediction for this particular target variable, which is term deposit subscribed. Okay. And then finally, it has the sample submission. So once you have used this trained data to, let's say, build a machine learning model on this trained data, make predictions for this test set. So this train and test only has one difference, that is it does not contain the target variable. And this is what you're expected to predict using various machine learning methods. Okay. Now, using the trained data, you need to make predictions on the test set. But what do you need to submit? For that, you refer to sample submission. So in any submission, you would include a unique ID for each call. And so this is the unique ID. So this is just a number to identify each row in the train and the test set. And the second one is term deposit subscribe. So whether the term deposit was subscribed post call or not. That's your target variable. So the first one is your ID. The second one is your target variable. And only these 2 columns should be there in your submission. Okay. Now, how to make a submission? There is a video here, and I will also demonstrate. This video is included in every hackathon for quick reference. Okay. And finally, what is the evaluation metric? So the evaluation metric for this hackathon is binary F1 score. And when we will, produce our first model At that stage, we will cover what is F1 score very briefly. So the objective of this hackathon is not to go deeply into each of these techniques, but actually solve each part of a hackathon using a Jupyter notebook or using a Colab notebook to get you a sense of what does a hackathon look like from the eyes of a hacker who maybe who is doing it for a long time and is doing well. Now, this is a very important part, which is called the public and private split. And many of you are basically must have, if you have already participated in Kaggle or DataHack, you would have seen a public and a private leaderboard. So essentially, what happens is your test set is further divided into 60% private submissions and 40% public. So what is 40% public? So as soon as you make your submission, you'll see a score. Okay, and let me just demonstrate that to you. So let's say, for example, you download the sample submissions. So for making a submission, what you need is a solution checker. And you can just upload this sample submission to check your basic score. So you should also always write a message in order to refer to your previous submissions. You see, so this is a sample submission. So your F1 score here is coming out to be 0, which is fine. But this is how it is done. So how do you make a submission? You use your solution checker to upload your solution file and the code file. Okay, so there's a question, can we use Spider? Yes, you can use any open source tool. You are free to use R, you are free to use Python, you're free to use Java or anything else that you want for a hackathon. Okay, generally Python and R are the most popular languages when it comes to data science and machine learning. So that is what we get usually in our hackathons as a code file. So for every so coming back to the solution checker, for every solution file, you can also you should also upload the code file. So what is the code file? Whatever Python script that you've written and you want to submit it along with the submission, that's your code file. Now let's come back to the problem statement. So just a quick recap. What we want to do here is make our predictions for whether a particular customer will subscribe to a term deposit after this campaign or not, based on all these input features. And then we had the public and private split. So when I made a submission, you saw that it generated a score of 0.0. So that was the score on your public leaderboard. So what does this mean? This means that from your test set, there is a proportion that is around 40% of your test set for which you need to make the predictions for 40% of the IDs that are randomly selected by us, by the organizers. You will be able to see a score for only those 40% values. The rest 60% values you have to submit along with the other 40%. But for that 60%, for the private leaderboard, that will actually finally decide whether you win the hackathon or not. Okay, you won't be able to see what score you're getting on that private 60%. You will be only able to see your score on the public leaderboard. Okay, and this sample solution file, you can, so all the data set, every time you want the data set, you will get it under the problem statement tab. So under the problem statement tab, you can then look at the problem statement, data description, sample submission, how to make a submission, evaluation metric, public and private split. How is it split? Sometimes it's also split on time. Okay. So let me just make it more clear for you. So what is public and private leaderboard? So let's just download the data sets. So I have already downloaded these data sets at my local machine. So let me just bring that. All right. So yes. So this is what your data set looks like. So I'm opening it in Excel for now. Okay. Just give me a moment. Yes, there you go. So this is what your train data looks like. Okay. So now if I were to, let's say, also look at the test data. So this is my test data. Okay, this is my test data. I'll just rename this sheet to test. Okay, this is where my test data. This is my train data. And let me create a sample submission as well. Okay, so what does the sample submission look like? Let me just open that as well. Yes. So this is what my sample submission looks like. Okay. So now what is the test set? The size of the test set is around 13,000 and the sample submission is exactly the same. So 13,565 and the test set is also same because these are your predictions for the test set that you need to submit. Now, what is the logic? Why do we need a separate public and private leaderboard? So if I give you access of the complete test set, so every time you make a submission, you exactly know. So if there are infinite number of submissions available to you, then for each submission, you can just get one value to be correct. So you try 0 once and then you try 1. And every time you will get to know that whether this prediction is correct or not, whether the second prediction is correct or not, and so on. That means that the essential part of hackathon where we are comparing what prediction score that everyone is generating, we are creating a leaderboard basis on the basis of that. So what happens is you can just maybe just try various values and get to the top of the leaderboard. So that is why you only have, so out of these 13,000 values, so out of these 13,000 values, you only have access to, let's say, around 5,000 of these values. So for example, when you are making a submission, your score will be generated on the randomly selected 50 to 100 values from here. And for the remaining 7,800, you won't be able to see whether your predictions were correct or not. So this ensures that what model, if you're submitting a model, if you're submitting a prediction, so it is more generalized, even on unseen data for which you were not able to see the performance of your particular model, you're still able to check the score. Okay, so and on the basis of these 7,800 values, then the final leaderboard is generated on the basis of which we say that you have topped the hackathon, you are second, you are third, only after we review the code. So once the hackathon is over, we get the codes from everyone, we review it on our end, and once the review process is done, then we announce the winners. So these are the hackathon winners, and this is the prize money for the hackathon, if that's a prize money hackathon. All right. So this is the overall idea of public and private leaderboard, and why do we need it? We need it. So you do not get the actual values for these 40%. Okay. You have to use this portal in order to see your score. So maybe it's accuracy, maybe it's RMSE. You are not given access to each value. You can access that score using this upload feature, and then at the leaderboard you will see all these scores. So some of the people have already made their first submission, and you can see that these are the scores that they've got. And this is only on the 40% of the data that is randomly selected, and not on the 60% of the data. So this is called your public leaderboard. So the private leaderboard is not live yet. It's not published because the hackathon is not over. Once the hackathon will be over, under those circumstances, you will see new scores for everyone. So for example, for this user, 0.51897 will be the public score. Then private score can be something different, can be lower than this, can be higher than this. And then the new ranking will be only based on the private scores, which is based on 60% of the data. All right. So having understood the problem statement, so my next part is nothing but to download the data sets. So as I said, I have already downloaded the 3 files. You can download, there are 3 files available. The first one is your train file, then your test file, and your sample submissions. So the train file contains the input variables along with the target. The test file contains only the input variables for which you need to predict the target. And finally, there is sample submissions, which is the format of the submissions that you need to make on our platform. All right. So now before you make your predictions, there are a lot of steps involved. Okay. Model building is not the first step. So let's see what are those. So once you've downloaded the data set, so now how do you use? So I'm using Google Colab here. If you are using it on a local machine, if you have installed Anaconda, Jupyter Notebook, or you're using Spider, R, or anything on your local machine, in that case, you just put all your files in a folder, whatever you have downloaded, and then you read them one by one using a read CSV function or any other function that you deem necessary. Now here, what I'm doing is for this, I'm doing it using Colab. So Colab works on the cloud as it is so it requires an internet connection. So that is one catch. It does need an internet connection to work because it is hosted on a browser. So we need to upload that data set on our Google Drive because we are using a Google account. So we'll upload our data set on the Google Drive, read our data set from the Google Drive itself, and work on it in this particular notebook. All right. So these are your initial steps. Now, once you have downloaded all the files, all the 3 files, you zip them in a particular folder and then upload it to Google Colab. How do you do that? So from google.colab, you import files. Okay. For those who are not familiar with Python, can just go through these steps that I'm going through. I will explain why we are doing, what are we doing at each step. So maybe the tool is not very familiar, but in my experience, Python is one of the languages where it has the code which is most readable. Okay, so you will definitely still learn a lot if you are already not familiar with Python. But just for everyone's heads up, we are going to use Python in this entire module for both of the days. So from google.colab, you can import files and just say files.upload. Okay, so once you say that, let me just see. Yeah, I'm just running this cell. Yeah, so then it will give you a choose files option. So using this choose files option, then you can upload your data set. So where is my data set? This is the data set that I'm working with. Okay, let me just upload it. Okay, now the next step that I'm doing, so these are terminal commands. So that is why there is an exclamation mark here. So you unzip the file using the unzip command. And once you have unzipped the file, you have access to all the 3 CSV files that were made available at the hackathon. All right. Okay. So again, you are free to use a Jupyter notebook. Okay. So you're free to use a Jupyter notebook. You can use your local machine to do this. Okay. If you have already unzipped the files and kept it, so you can, also upload the files one by one. This is just a faster way to do it. Okay. So yeah, so if you have network issues with this live session, I assure you that the recording for this will be available to everyone, and you can go through the recordings once the session is over. So let's see. So I've also upgraded the library called Cbond, and this library is what we are going to use to visualize our data set going forward. And once you have unzipped the data, you have access to all these files. So just for everyone's reference, I've also pasted the problem statement from the original platform, which is the hackathon platform. So this problem statement is already pasted here as well for quick reference. So we have already gone through the problem statement. We are trying to predict whether a particular customer will subscribe to term deposit or not, given the marketing campaign. And then this is the data description. This is a table that I've copy pasted from the hackathon platform to an Excel file, and then I've just pasted that here. Okay. So now all these variables, so you can see there are 16 variables apart. So this ID variable is nothing, but it just identifies each row. Okay. And then the rest of the 16 variables can be used for model building and making your prediction. Okay. So again, one more part that I want to make clear is this is not a hands-on session. So you are not expected to write code along with me. Okay. So you're free to you're free to do that if you want. If you already know a lot of stuff and you want to do that, you're free to do that. But if you're participating in the hackathon for the first time, and even if you're not, I would advise you to just focus on what I'm covering here, because I'm going to share the steps. So having looked at large number of hackathons, me and Nikhil have identified some structures to how do you tackle a hackathon, how do you improve your model, and ultimately make a submission that lands towards the top of the leaderboard. So that's what everyone wants, right? So that is what we're going to cover. So don't worry about following each of these steps. As I said, the recording is available. Recording will be available to you guys, and you will be able to access them after we have completed this session. All right. So if you just want to go through these variables, so what are some of the variables that you see? So there is customer age, then you have the type of the job of the customer, then you have the marital status of the customer. Okay. Then you have the education level of the customer, whether the customer has defaulted in the past. So what is a default? For example, customer subscribed to a loan and did not pay on time. That is what we call as default. Then the balance of the customer. So these are existing customers of the bank. So that means we have also the balance information for these customers. Housing loan, personal loan, has the customer taken a housing loan, has the customer taken a personal loan. Looks like categorical variables, which will just say whether a person has had a loan in the past. If he had a loan, he or she had a loan, in that case, it will be 1. Otherwise, it will be 0. Then we have communication type. So type of communication made by the bank with the customer. Maybe it looks like whether it was a telephonic call, or whether it was an email, or it was something else. Whatever it was, how did we reach out to the customer the last time? Then number of contacts in campaign. So number of times you made a call to the customer, or number of times that you reached out to the customer. Then you have days since previous campaign contact. Number of days passed since the customer was contacted in the previous campaign. How much time has it passed? Okay, how much time has passed since, let's say, the last time we reached out to the customer? And then number of contacts is number of contacts made with the customer during the previous campaign. What was the outcome of the previous campaign? And then ultimately, term deposit subscribed. That's your target variable. All right. So now we can see that these are 16 variables available to us. ID is just an identifier column. So I want to make it very clear. So ID in general, it is a rule that you do not use the ID variable as a part of your submission. So for example, I would not use your roll number to predict whether you will pass or fail in an exam, right? Right. So I would use your historical test performances or something else. I would not use your roll number, because that's just based on some arbitrary criteria. Similarly, in any machine learning problem, you do not use the ID variable to make your predictions for the hackathon. And generally, it is always mentioned in the guidelines and the rules for the hackathon that the ID variable is not to be used as part of the model. ID variable is just to identify each row of your particular customer or particular row in a data set. And this ID variable is to be used to only refer to each row in your train and test set. The variable term deposit subscribe, that's your target variable. It has binary values, and we need to learn to predict this variable given our 16 variables as features or input variables. Features is nothing but a different name for input variables that you're going to use. Now the next step, what is this next step? Okay, so this step is called hypothesis generation. So if you remember, my first step was problem statement, problem definition. So we tried to understand the problem. What is it about? We looked at the variables. Now, without looking at the data, and this is something that is done in real data science projects as well. So without looking at the data, you, on the basis of your common sense, your domain knowledge, or your understanding, you list down some questions that you would want to answer beforehand. So for example, you already know that there are some variables available in your data set. Okay, and on the basis of these variables, okay, you can already say that there are some hypotheses. So for example, are younger customers more likely to subscribe to a term deposit as compared to old customers? Are people with higher bank balance more likely to subscribe to term deposit than people with low balance? Thirdly, does a married person have higher chances to subscribe, or does an unmarried person or a bachelor has a higher chance of subscribing? Okay, so these are some of the questions that you write beforehand. And often, in my experience, I can tell you, when you're working on a data science or a predictive analytics project, there are hundreds of hypotheses that are generated before a problem statement is defined for a data scientist. When a problem statement is defined, there are hundreds of hypotheses that are going to be generated, because on the basis of that, then you do data collection. So the difference between hackathons, and that was also mentioned in our about section of this particular event, that the difference between hackathons and real data science projects is, in real data science projects, you are not provided the data set beforehand. You define your problem statement. Once you've defined your problem statement, on the basis of that, then you say that yes, these are the data sets that I need for making my predictions, or solving the particular business problem. These are the data sets that I need. But in a hackathon, these data sets are already provided to you. The problem statement is already defined for you. But trust me, in a real scenario, this is a step that has a lot of value. And even in hackathons, what I've observed is, whenever I go through this way, I'm able to create better features for my model and able to understand the problem better, and thus do better feature engineering, which is one of the most important parts about winning a hackathon that Nikhil will cover in the second stream. All right. So having understood how do you create all of these, you know, uh, hypothesis. So again, these are just 4 hypotheses. On the basis of input variables, you can create more. And I'll leave this as an exercise. So for those who seriously want to, learn how to participate in hackathons, focus on what I'm providing as exercises. This will really help you to, get your mind running and uh, get your focus on how you're going to solve this hackathon and how you're going to do well. Okay, so why have I listed all these questions? So I've listed all these questions because then when exploring the data, and what is data exploration? Data exploration is nothing but plotting, visualizing the data, exploring the data, and seeing what is the information that is provided. Okay, and on the basis of that exploration, we'll try to answer some of these questions. Okay, and once we have answered these questions, we will have a much better understanding of the data set at hand, which is essential and very important in a machine learning project. Exploratory data analysis, most important part, because on the basis of how well you have explored the data, you are able to create good ideas for feature engineering, good ideas for creating the best models, and good ideas for finally feature selection. All right. So now let's see. So here we have imported some of the libraries that we're going to need in this and in these 2 notebooks. So we have imported them here. So NumPy, Pandas, Matplotlib. NumPy, Pandas are to work with the lists and data frames that we have. Then we have Matplotlib, which is essentially to plot some of these. So to visualize our data and do exploratory analysis. And Seaborn is another library that is again used to visualize. Then from sklearn, so these are for model building, and these will be covered well in the second stream. And when we will build our first model, so that is when we will see the major use of all these sklearn elements. Okay, so once you have run this, then we venture into EDA. So before going into EDA, you identify what are the files that are available to you. So you have available to you sample submission, train file, and the test file. Now let's go on and read and have a look at each of these files. So for example, sample submission, train, and test. So what is a sample submission? Sample submission is nothing but it just has 2 columns: ID, term deposit, subscribed. Okay, and these are the ID variable. This is term deposit subscribed. Okay, and you can see and look at them. And so these are some of the ID variables, some of the IDs of each of these customers whom the call is made, and this is the prediction for which you want to that you would submit here. Okay, a sample submission file contains 2 columns: ID and term deposit subscribed. We'll use the same format to submit to AV platform, that is DataHack. We don't need the sample submission for now because right now we want to explore the dataset, the input variables, the target, and see what are the insights that we can capture from there. Okay, so now let's go and explore the training and the test sets. So a brief look at the dataset, see the dataset shape, uh, target distribution. So this is just so head is just to see the top 5 values. You can mention head 20 to see the top 20 values, and this is just to get a gist of what is contained in a particular data set. Now if you want to have a look at the test set as well, so you can do that using this, and the only difference between the two sets will be the last variable. So the last variable is missing in the test set because that is what you need to predict. So you can then rename the ID and the target column. So often the target column might have a longer name, might have a custom name. So you can store it in two different variables. Okay, so for example, the ID call and the target call. So once you do that, then the dataset shape. So what are the number of customers that are available in the dataset, and you can look at that using the train and the test set. So train contains 31,647 customers and 18 variables. So including the ID and the target, test contains 13,500 samples and 17 variables. Now, what is the target distribution? Let's look at our target variable. So looking at the target variable, so we have in the target variable, you can use the value counts function to do that. And normalize equal to true just ensures that you're getting a ratio and not the exact count of zeros and ones. So in your target variable, you have the target call, which is nothing but the term deposit subscribed variable. So we are just working with the trained data right now. We are not working with the test data because trained data has the target variable. And this will help us in answering our hypothesis questions that we listed earlier. So, and so to communicate our findings visually, so that is where all these graphs and plots come into the picture. Okay, so for example, let's see. So using Cbond, which is imported as SNS, you can do a count plot and see more than 25,000 out of these 31,000 customers in our train set. More than 25,000 have not subscribed, which is acceptable. So only around 10% of the customers have subscribed to a term deposit. So usually the marketing campaigns. Okay. Usually in all these marketing campaigns, what you see is the conversions are often much lower, okay, close to 10%, 5%, even 1 or 2%, depending on the product that you are, selling. So quite obviously, the data is very imbalanced. So what do you mean by imbalanced? So for example, if it would have been zeros 50% and 1 is 50%, so in that case, you might call that the data is very balanced, and there are equal number of customers lying in both these classes. But in this case, you see that there is a high imbalance in the data set, and only 10% of the customers have subscribed to the term deposit. Now let's look at some of the variable data types. You can use .info to do that. Okay, and so .info is basically this. So .info can give you ID, customer age. So all these values. So for example, ID is an object. So what is an object? Object is nothing but it is a string. And then the customer age is a float. Then you have int 64 as well. So these are integers. So float is a continuous number and int is then just an integer. Objects are all categories. Okay, and you can see why that is true. For example, customer age is a float. So for example, customer age is a what is a customer age? Customer age is a numerical variable. So that is why it is a float or int. So and then the objects, for example, personal loan. So whether the customer has a personal loan or not, that's object. Okay, then looks like we have a mixture of data types. A lot of these variables are object data types. Object data types are used to store strings, as I just mentioned. Now the very important part in so a very important part in this is observing the null values. So often So often what we see is, yeah, so that's a category. Personal loans is a category. So often what we see is the null values are there in a data set. So for example, you're not able to collect all the details regarding a customer. Okay, that's often the case. Sometimes the customers do not fill the forms properly, and the missing values can have a lot of sources in that manner. It can just be random missing. So just maybe a data entry operator missed out on this value. Maybe a customer missed out on a value and did not submit what he wanted to submit. And there are often other reasons as well, such as, let's say, the server went down and was not able to collect the data during a period. So all these are missing values. So there are reasons for missing. Sometimes there are systematic reasons as well. Sometimes they are random reasons. So for example, if you want to check out on how many missing values are there in each variable, that you can do using this function. And what we have here is that days since previous campaign contact has 81% values missing. So on the first look, and the rest of the variables also have some missing values, which is very low, like 2% or 1.3%, which will not hurt me much. And I will also treat them when I will build my first machine learning model, because machine learning model, most of them do not, work on missing values by themselves. Okay, so what we see here is days since previous campaign contact has 81% missing values. So here you would use your sense to understand. So if this is missing, so the reason might be that this customer was never reached out in the previous campaign. So that is why these are missing for 80% of the customers. Okay, so these are new customers and they were not reached out in the previous campaign, and that is why most of this is missing. That is my hypothesis, and I will confirm this hypothesis going forward. Okay, well, there are some other missing values as well in customer age, balance, and last contact duration, and we will treat them when as and when we need to going forward. But these are very small, so we are okay with that. Now, if you want to check out the unique values in each variable, how do you do that? So you use train.nUnique. So for example, ID has 31,600 unique values. Customer age has 77 unique values. So all these are continuous, or let's say, 31,000 means that for each customer, there is a different ID. And that is where you have every ID is different for each customer. And this is just used to identify a particular row. Customer age, of course, has numerical values. That is why it has 77 different values. It could have been more, but here we have 77. Job type. So this is a categorical variable, and we see that there are 12 values here. And similarly, you can see for the other variables as well. Last contact duration is 1400 because again, this is a numerical variable. And this was also seen from the D types method that we use to see various. So whether a particular variable is an object, whether a particular variable is a numerical, int, float, and that also gave us a very similar kind of information as is given by .nUnique. Okay, now we come to the steps. So this is so till now we were just having a feel of the data set. Okay, looking at the number of customers in my train set, in my test set, looking at the various variables, number of unique values in each variable. We were doing just that. So now it's time to get deeper into our exploratory data analysis. So what do we do there? So there are mainly, most of the times, there are two steps to it. So the first step is to see. So the first step is to do univariate analysis. Now, what is univariate analysis? In univariate analysis, what you do is you take a variable one by one. So let's say there are 16 variables available. You pick one variable one at a time, and you see what are the insights there. What is the distribution of that variable? Okay. What is the frequency of each of the categories in that variable? How is it related with the target variable? Sorry, so how is it related to the target variable is then, studied in bivariate analysis, where we have multiple variables to deal with. Right now, in univariate analysis, what you do is you pick one variable at a time, you see its distribution. And on the basis of that, you just take notes. you take notes in your notebook itself. So what I do is I generally, when I'm working on a data set in the notebook itself, like you are seeing in this collab notebook, you would take notes for each of the observations that you have from your particular data set. So for each variable, you would identify the distribution. You would look at the number of so frequency of each of the variables. And so as I said, there are two types of features that we have. So categorical and numerical. And also our target is binary. So that is also a categorical, like a categorical variable. So under categorical also, so just an external knowledge, not so here we have most of the categorical variables as nominal. So what is nominal? Within categorical, there are two types of variables, nominal and ordinal. So what is an ordinal variable? So for example, low, medium, high. So let's say a categorical variable says low, medium, high. That's an ordinal variable because it has an essential order to it. Low is lower than medium, medium is lower than high. Now, another categorical variable, for example, gender, male, female. So both these categorical variables do not have any order within them. Okay, so this is like a nominal categorical variable. And the earlier one, low, medium, high, is like a ordinal categorical variable. Okay, so that has like characteristics of both numerical and categorical in a sense because it has an order to it. Now then the third type is purely numerical variables, which are just numbers. So for example, age, balance, all these are direct numbers and these are called numerical variables. Okay. Yeah, so true and false will also come under categorical variables. So so let's look at the train columns. So these are the train columns that we have. You can just use dot columns to with that. You can segregate the categorical and numerical variables just like this. So on the basis of the D types that we looked at earlier. I'm sorry. Yeah. So on the basis of the categorical variables that we saw earlier, we saw that job type, marital, education, default, housing loan, and all these are categorical variables. We are storing them as a list called cat underscore calls. Then you have numerical columns. So numerical columns is C for C in features if C not in cat calls. This is a list comprehension that we have used here. And we just say for all the features which are not categorical are numerical because there is no third type. So let's start our univariate analysis. We will start with our categorical variables. Okay, so so let's see. So pie charts. So everyone must have seen some level of pie charts everywhere, right? So pie charts essentially give you the information for various categories. So what is the proportion for each pie chart? Okay, so for example, okay, so let's have a look at the categorical variables now. So yeah, so for categorical variables, what do you see here? We see that we have, so using this function, we can, yeah, so this is what you see. So these are the percentage of values. So for example, for job type, you have 11% in admin, 16% as technician, 21% as management, 22% blue collar, 1% unknown, 2% students, and so on. So this is the first snapshot of what your overall categories look like in each of these variables. So in job type, in marital status, in education, default, housing loan. So you see housing loan also half of the people have an housing loan, also half of the people do not. Personal loan you see 84% do not have. Default 98% have not defaulted, which was expected. Then 60% are married, 28% single, 12% are divorced. Then you also have communication type. So communication type, you see 65% cellular, 29% unknown. So there, so we don't know whether it might be possible that, so this information is not available to us. So we might have reached out to these customers in the past or might not have reached out to these customers. And that is why this is unknown. Okay, and 6% is telephone. Okay, so then you see for the different months, you see that for August, you see 14%. So most of the term deposits for so for example, month is, so what is month? So you can always, go back and refer to the data dictionary. So month is month for the last contact made with the customer. Okay, so most of the customers were reached out in last May. Okay. Yeah. So this is not so a month is again a categorical variable or an ordinal variable if you want to be very specific. Now previous campaign outcome 82%. So this is a number that we saw earlier as well. So 82% for 82% of the campaigns, previous campaign outcome is unknown. Now if you go back, we saw 82% values are missing, where 82% were missing in days since previous campaign contact. So what is the inference? So what is the inference that you can draw? So the inference that you can draw from this is that these customers were never reached out in the previous campaign, and that is why their campaign outcome is also unknown. So this, confirms our hypothesis that we said earlier, that 82% of the customers, 82% of the customers were not reached out in the last campaign. Now you can also do a count plot for these univariate analysis. So let's do a count plot now. So this count plot will essentially give you the count information and not just the percentages. So here you see that the largest group is blue collar management and technician. These are the top 3 groups. Most of the customers are married, and some of them are single, and some of them are divorced. So all these plots are part of the exploratory data analysis, which we have started after the hypothesis generation step. So just to make it very clear. In education, you see secondary, tertiary, primary, unknown, and so on. So what is the default? Default, most of the customers have not defaulted. So it's a no for most of them, as we also saw earlier. And so more than 30,000 customers. Then you have the housing loan. So here it's just the same snapshot, but in terms of the count for each of the categories. So that is what we see here. Now the bivariate analysis with target. So if you see the bivariate analysis, let's see that. So bivariate analysis, what is it? So first, before even going into bivariate analysis, what is a bivariate analysis? Okay, so in bivariate analysis, what you do is you check relationship of one variable with the other. And most of the times it is the target variable. So if you remember, if you go back, we generated a few hypotheses, right? So we did not generate just for the sake of it. We will use them here. So for example, some of the hypotheses, if you want to look at, does a married person have higher chances to subscribe or not? Okay, so in order to check this, you would want to work with 2 variables. One is the marital status. The other variable is the target variable, which is whether the customer subscribed for the term deposit or not. And using both these variables, then what you can do is, then you can check the relationship and see how well you can identify that relationship, right? So this is what is a part of bivariate analysis. Okay, so what you can do is you can one by one answer these questions, and while answering these questions, you might land up on new questions. So on the basis of the insights that you generated with a bivariate analysis, you can then generate new questions from that insight, and then going forward, you can answer further questions. So for example, let's start with the bivariate analysis. Here we go. So with the target, here we are doing a bivariate analysis with the target. So what do we see here? So this is the, so this is the percentage. Okay, so 25% of the, so as you see, 0 is not subscribed, 1 is subscribed. Okay, so you see in the management, most of them did subscribe to a term deposit. Okay, and then so the ones are greater than the zeros. So this is a very insightful variable, as you can see clearly. In married and single, you see that single people are subscribing more to the term deposits than your married people. And you can observe uh, all these things from various variables. So for example, housing loan, you can also check. Personal loan, you can check. So those people who have who have a housing loan, okay, they are subscribing to, they are not subscribing to the term deposit, but those who do not have a housing loan are subscribing more to the term deposit. Okay. Okay. So this is what we have. So this is a combined function. So, and I encourage, so once I've shared the notebook with you guys, yeah, so it will be shared, and you can use these functions in your own notebook to, build models in your hackathon, or build uh, visualizations to observe what are the key insights from your particular data set. And these functions can be directly used for doing that exactly. Okay. And here we have observed some of the instances right away. So now let's check, do married people have more chances of subscribing to a term deposit? We already saw that in this graph. So let's see it more clearly. So to see it more clearly, we plot another horizontal bar, but this time for each of them, we are, let's say, plotting a rate of subscription. You can call this a rate of subscription. So for all the single people, what is the percentage of people who have subscribed? Okay, then for all the divorced people, what is the percentage that have subscribed? Then for married people, what is the percentage that they have subscribed? Okay, this is what we have. So for single, we see that the percentage is the highest. So initially, we might have hypothesized that single people are less likely to subscribe to term deposits, but that's not the case. Okay, so that's not the case. This is, this can be, so your hypothesis can always be wrong, but that doesn't mean you don't create hypothesis. Your hypothesis could be wrong. Okay, and the data set generally answers whether your hypothesis is wrong or right. But it's very important to create those hypotheses in the first place, so that actually, you can finally answer them. You can finally ensure that they are correct, or ensure that they are not correct. Here we see that it was incorrect clearly. Then for numerical features, so these were for categorical features. So this is the one hypothesis that we noted down for the categorical features. You can also list down similar hypothesis for whether owning a housing loan results in higher subscription rate or not. We saw that not owning a housing loan means a higher subscription rate. So all these things are, yeah. So how do I form the hypothesis? Hypothesis is generally formed on the basis of your common sense, your understanding of the problem, and finally your domain knowledge. Okay. And so for example, you're working in a banking domain, you would understand what are the things that will impact the target variable at some level. But in a hackathon scenario, what you do is you do your online research. You try to understand the term. You try to understand, let's say you don't know what's a term deposit. Google it. Try to understand the problem statement. Okay. Try to understand what are the variables available. If you don't understand them, ask in the discussion forum. Write a mail to the organizers. Okay. Try to understand the problem clearly. Then list down your hypothesis. What do I think will impact the target variable? Okay. And this is where your structured thinking comes into the picture. So when you are, sitting in that interview for data science, often there will be rounds of structured thinking as well, where you will be provided a case study. Okay. So there you will have to have a structured approach to how you approach the problem. Okay. And there, this hypothesis generation uh, approach will really help you to train your mind doing that exactly. So for example, here we generated the hypothesis on the basis of our understanding of the problem statement. Similarly, you can use these hypotheses, use the same approach of hypothesis generation in order to solve, let's say, a case study, or let's say a guess estimate when you're asked in an interview. So many of the data scientist interviews involve a guess estimate or a case study as well. Okay, they might involve a coding round, they might involve a case study, guess estimate, all these things. And I believe that hypothesis generation step, if you perform it in every hackathon, you will also enhance your that skill as well. So hackathons are not just for winning prize money or whatever. These hackathons can actually, make you industry ready, make you ready to face any new kind of problem that might be thrown at you during an interview, a new data set that might be given to you to work on. So often, uh, since everybody is interviewing virtually right now in this pandemic situation, okay, so it is often the case that you're given an assignment for a couple of days to work on, and then you go get back with a notebook with your analysis, and then the interview process goes on further after that. So coming back to this stage, so that is how you create your hypothesis on the basis of understanding of the problem. So now, do married people have more chances of subscribing to a term deposit? We said no, single people have more chances of subscribing. Then we have looked at categorical combination of categorical and the target variable. Okay, so now, and we have looked at the univariate analysis of the categorical features as well. Now we will go on to do the univariate analysis of numerical features. Okay, so numerical features, what do you see? You can use a box plot here. So what is a box plot? Box plot basically will plot your, so a box plot will basically give you, so this is your median value for the particular numerical variable. So for example, customer age, this is the median value. There are some outliers in your customer age, which is very clear. And then you have all these values lying between these two whiskers. So this is what you call as a box plot. And then you see that all these variables, for example, the balance variable has a lot of outliers, age had some outliers, and then you also see a day of month where you see, so day of month doesn't have outliers because it's all its values will lie between 1 and 30 or 1 and 31. Last contact duration has a lot of outliers. So we see that there are a lot of outliers in each of these variables. So a good idea. So instead of looking at just the box plot for each of these variables, what you can do is you can look at the distribution as well. So what does the distribution look like? Let's check the distribution. So if you remember a histogram, the KDE plot is very similar to histogram, but it calculates the density. It gives you a continuous smoothened function of your frequency distribution of your particular continuous variable. So for example, most of the customers lie between the age of 20 and 50, as you can see from this plot. And this is the mode value. For example, balance is generally, so if you have worked with enough banking data sets, you'll see that balances are generally very skewed. Most of the customers have very low balances in their bank accounts. And a few customers have very high balances, the high net worth customers. So this plot for the balance in banking generally looks like this, where it is left skewed. Okay, and so if this is left skewed, then you can see clearly these are the balance of the customers. Then day of the month, again, so day of the month is, so its distribution doesn't give me much information. Okay, then the last contact duration. So here you can also see that for last contact, this is also left skewed. So this is also right skewed. So right skewed is basically when you have the bell curve towards the left side, and left skewed is something where you have the bell curve towards the right side. Okay, so this is right skewed, and this is also right skewed. Pardon me if I said left skewed earlier. So this also had a few outliers, as you saw in this one. So last contact duration had a lot of outliers. So that is why, and the most of the values are concentrated here. Okay, so that is why this is also left skewed. And you can see that from this particular plot. Number of contacts in campaign is again left skewed. This is a tri-model distribution in days since previous campaign contact. So there were, so let's say a big campaign happened around 180 days ago. Then a big campaign happened 1 year ago. So this is 365 days, this is 180 days. This is 90 days. So basically maybe they are doing a campaign every 3 months, a big campaign. And that's why you see a spike for days since previous contact in this particular plot. Number of contacts in the previous campaign, you can again see that this is a left skewed plot. So number of contacts done in the previous campaign to this particular customer can be you can get it from here. Okay, so just to give you an overall picture, till now we have defined the problem statement. We have went to the hackathon platform, downloaded the data sets, understood the problem statement. Then we looked at the data sets to just get a feel of them. What are the number of rows? What are the number of columns? What are these columns? We generated hypothesis in order to say like these are the questions that I'm going to answer via my exploratory data analysis. Then we picked up firstly the categorical variables. Within categorical variables, we did some univariate analysis. Okay, we saw the number of we saw the frequency distribution for each of these numerical analysis, and then finally we also saw the relationship of all these categorical variables with the target variable, that is whether the customer subscribed for a term deposit or not. All right, so now bivariate analysis, KDE plots. So that's right now we saw the univariate analysis for numerical variables. Okay, so problem statement, hypothesis generation, exploratory data analysis. Within exploratory data analysis, univariate analysis of the categorical variables, then bivariate analysis of categorical and the target variable. Then for numerical variables, we saw the univariate analysis, we saw the box plot, we saw the distributions, and now we will see the bivariate analysis of the target variable and the numerical variables. Let's see that. So if you look at this, okay, and this is a very good plot. This is called a filled KDE plot. So what you see here is for different ages, what is the subscription rate? So it varies from 0 to 1. So you see that for very young customers, the subscription rate is very high. Okay, so these are mostly students. Okay, and then after that, you see it's dropping. It comes down to the average. Most of the customers anyways lie on this average. For the older customers, you again see that it rises up. Okay, and so on. So for example, for most of these customers, which have age this high, these are very low in number. So this is not very significant. But as you saw in the distribution earlier, most of the customers lie in this age, so 20 to 60, right? So 20 to 60 can definitely give you a fair idea of how this subscription rate looks like. And you see that for the older customers, you see a higher subscription rate to the term deposits than the younger customers. Now, for the balance, what do we see in the balance? So in the balance, you see again, for the higher balances, there is a bit of a higher values in the subscription rate. In this range, it's very high. And for these customers, it's just that there are very low number of customers in this range. And that is why you see this whole spike in this area. For day of the month, you see that towards the first date and the last date of the month, you see a high term deposit subscription rate. What could be the reason of that? Can someone post it in the chat section? Towards the end of the month and towards the beginning of the month, you see a spike. Salary, that's great. Yeah. So most of the people get their salary credited during the last day of the month or during the first day of the month. And that is when they have their balance accounts spiked. And if you reach out to them during that time, that's the best time to get them subscribed. Okay, and this is a very good insight that you can get from this EDA. Now, last contact duration. So you see that if your last contact duration lies in this area, 10 to 12, 2000, and if you just go back to, so most of it lies between 0 to 1000 anyways. Okay, so 0 to 1000, it just rises. And these values are essentially outliers. Okay, these values are just outliers, and from 0 to 1000, you see that it's continuously rising. So if your last contact duration was higher, okay, that means the customer is interested in your products and is interested in buying products or subscribing to products via a telephone campaign. So they have a higher probability of getting subscribed. So that's why as you increase the call duration, you have a higher subscription rate. Okay, Now, a number of contacts in the campaign. So if you have made, so for the number of contacts, you don't see a very large change, but as you're increasing the number of contacts, it's essentially it has a trend of going down. So an essential idea is to not reach out to a customers a lot of, so just reaching out to customers a lot of times in a particular campaign is not very helpful, and you should optimize on that number. So you should make effective calls rather than focusing on quantity of calls. You should focus on quality of calls. So days since so again, this was something. So if you have reached out to the customers around 1 year ago, and these are the customers who are more likely to subscribe, more information on this data set is not available. So we just want to just visualize how this particular variable is impacting the target variable, which is term deposit subscribed. Now, in the density, so in the number of contacts previous campaign. So in the previous campaign, so there was a particular contact which we reached out more than 250 times. And that is why this graph is like this. So if you want to, you can just treat one of these outliers. What is treating the outliers? You can drop this outlier from your analysis, and then you can visualize it more clearly. So essentially what we see is as we increase the number of contacts in the previous campaign, there is an increasing trend. In the current campaign, it was generally decreasing trend very clearly. And in the previous campaign, if you have reached out to customer more times, it's increasing. So that's an interesting way to look at it. And yeah. So all right. We have seen a couple of requests for a break. So we will not take a very long break, and let's just take a break for a couple of minutes, or let's say 5 minutes, and then we will resume. Sounds good to everyone? All right. So I'll be here, and we will continue with our discussion. Okay. All right, guys, so it's time to resume now. Okay, so as we were discussing the bivariate analysis, and we saw that we had come across various kinds of relationships with the target variables, and it was quite insightful. We got really good insights from various variables, and we saw that uh, from these density plots. So one of the interesting insights was regarding the end of the month. Okay, and this is very useful as you can then use this insight. So without even going to the predictive analytics stage, from the EDA itself, okay, you can derive a lot of information from the EDA itself. You identify that for the first few days of the month or the last few days of the month when the salary is getting credited, that is the time that you should call these customers. So without having any domain knowledge of the problem, you can identify such kind of relationship, and that is what the hackathon is about. Okay, so there are people. So you guys can see my screen, right? Just wanted to make sure. Yep, thank you. Yeah, so as I was just saying that uh, when you come across a hackathon, you will always encounter a new problem statement. Maybe you have worked on that domain, maybe you haven't. Okay, maybe you are from a finance background, maybe you are from an e-commerce background, maybe you're working in consulting, but it doesn't matter. Okay, data has just one language of numbers. Okay, and you need to understand the problem statement. Go do your research from Google, talk to a few people from the industry if you have access to them, and discuss amongst your peers, the participants. Okay, and after that, then you can get all these insights from the data itself, and that can help you answer a lot of questions, right? So after having gone through all these interesting details, now we can also one by one answer the questions in that we generated in the hypothesis generation step. Okay, so in the hypothesis generation step, we we were trying to answer a few questions, right? Now, so how can we do that? For all the people, for all the customers who did subscribe to a term deposit, and for all the customers who did not subscribe to a term deposit, we can compare the average of balances, we can compare the average age, and we can compare a lot of things. But at the same time, what we can do is we can also compare their median. Now, why do I choose a median instead of mean here or the average? Because we saw that the all the most of the variables have a lot of outliers. So when the variables have a lot of outliers, in that case, comparing the median is a much better idea. Because just because a few heavyweight high net worth customers did not subscribe to term deposit, and because of that, the average of people who have average balance of people who have not subscribed to term deposit turns out to be higher than the other category, then that case they might reveal misinformation. So that is not information, because that's a wrong interpretation of the same data. These are very few customers who have very high balances. They might already have a lot of term deposits with them. They do not want to subscribe. But that doesn't mean that you can directly draw inferences from these high value customers. And the average, what average is always average or mean is always influenced by very large values or very small values in that for that matter. So what do we do to tackle something like this? We use a median. And how do we use median here? We calculate the median for both the categories: people who have subscribed to a term deposit, people who haven't subscribed to a term deposit. Calculate the median for both of them, and then compare it with each other. Okay, now let's see. So what do we see here? Yes, so median customer age for people who have not subscribed, it's quite high. Then the people who have subscribed, median balance you can also see, and you can do it for all the continuous variables or the numerical variables that you have, right? So as you can see from this stage. All right, so do people So then we can answer all these questions that we created in the hypothesis generation step, remember? So do people with a higher bank balance more likely to subscribe to term deposit than people with low balance? How to answer that? Let's see. So median. Yeah, so you see, if you see the plot, median balance of customers not subscribing is around 400, whereas the median balance of customers subscribing to term deposit is 800. This definitely supports our initial hypothesis that says that people with higher balance are more likely to subscribe to term deposit. It's very simple, right? What is term deposit? It's a fixed deposit or a recurring deposit that you make to the bank. Only, okay, it makes sense to us, and now we can interpret it, okay, because people who have balance, people who have money are the ones who will subscribe to all these financial products, right? Where you can use that money to get extra revenue for yourself. Okay, and this is what we have here. Now, another hypothesis was, does the length of the call made to the customers tell us anything about their chances of subscribing? Okay, so let's check the last contact duration. Last contact that happened with the customer in this campaign. Let's check the median of that. Here is the median. So for people who have subscribed to, so for the last contact duration, the median comes out to be much higher. Okay, so we can see from the above median, last call duration made to the customers not subscribing is around 150 seconds, and the median last call duration made to the customer subscribing to a term deposit is around 450 seconds. So yes, our hypothesis seems true. So higher length of the call means that the people are subscribing to, so, and that's for the last contact made to the customer. Okay. Now another hypothesis was, are younger customers more likely to subscribe? So in order to do this, so now some people might ask, in EDA, do I change the data in some way or not? The answer is, there is no hard rule. You can alter the data according to your need, according to your understanding. So for example, here we are comparing the age. So for the age, what do we see? We want to understand whether old age people are more likely to subscribe or not. Okay, that's what we want to see. Now what we can do is, we have this continuous variable. We can divide that continuous variable into various buckets. That's called binning also. Okay, so you divide that variable into various buckets, and for each bucket, then you check the subscription rate. So essentially, taking a numerical variable and dividing it into various categorical variables. And for each categorical variable, then you can check whether the subscription rate is high or not. Here we are dividing them into two parts. One is people older than 60 years of age. We are calling them elder customers, old age, and people who have age less than 60. That's a people less than age of 60. So let's see here. Okay, so the older people have a much higher subscription rate as compared to younger people, as we can see from here. So now this 60 can be taken down to 50 as well. Okay, and you can check that as well. So for example, you can do simply this. You just check for 50, and here also it comes out to be true. So if you're calculating for so the subscription rate for older customers and for the younger customers, you see subscription rate for the older customers is much higher than the younger customers. Okay. So this is the bivariate. So we have essentially, we listed down some questions in our hypothesis generation, and those were related to both categorical and numerical variables. We looked at both, right? And now we are able to answer some of these questions very clearly. Okay. Now the next part is related to, so till now we are just talking about one target variable, till the subscription rate. And with that target variable, what we are looking at is what is its relationship with various input variables, such as the categorical variables. And then you have the along with the categorical variables, you also have these numerical variables, and you looked at the relationship of the target variable with each of them. It is often the case that some of the input variables might be correlated with each other. Okay, and the bivariate analysis essentially means relationship between two variables. Now that variable could be the target variable, or both could be your input variables as well. Okay, but remember that correlations are only to be used for numerical variables and never to be used for categorical, because categorical variables do not have an order to them. So a Pearson correlation, or say, let's say a Spearman correlation, you can only use for a pair of numerical variables to see how well correlated are both of them, right? So let's see. So this is your correlation heat map. So if most of you must have already studied correlation somewhere or the other. For those who have not, it simply says that what is if I say one variable is increasing with the other. Okay, so one variable is increasing with the other variable at some rate, and if that rate is positive, okay, so for example, my speed, so let's say I'm making a run, and the time required to cover 1 kilometer. Okay, there's an inverse relation between two of them. So more the speed, the lesser time I will take to cover a particular distance. Okay, so then the correlation is negative. One of them is increasing, the other is decreasing. Okay, now the correlation can be positive as well. Okay, so with more exercise, I'm losing more weight. Okay, so the duration of my exercise in the entire week or the entire last 6 months and weight lost, they will have a positive correlation. Okay, so here what I'm doing is, so the value varies from -1 to +1. And what I'm checking here is for each of these numerical variables, for customer age and let's say balance. And so for all of them, we are checking the correlation values. We see that most of the correlation values are quite small. Okay, and when we have correlation values, let's say less than 0.5 in both the directions, like within -0.5 to +0.5, we say that they are not very highly correlated. Often in linear models, what we face is a problem of multicollinearity. So where a lot of the input variables are correlated with each other. And for applying linear regression, and in order to interpret the coefficients correctly of a linear regression or a logistic regression for that matter, you need to remove this multicollinearity. So if there are two variables who have very high correlation with each other, 0.7 or 0.8, maybe you combine both these variables to create a new variable. Or in the second scenario, what you can do is you can then instead of combining, you can drop one of the variables and just keep one of them, since essentially they are very highly correlated, and the information, the correlation between both of them is very high. So you can just keep one of them, and the other's information is already included in the one. You might lose out on a bit of information, but you gain that in terms of interpretability, as now you can read your coefficients more clearly for any linear or logistic regression. So this is where your continuous variables come into the picture, and you check all these relationships with the, you check all the correlation values and see that how highly correlated it is for each of these variables. So let's say there were two, right now we just have a balance. Okay, let's say there was another variable called balance in previous quarter. Now that could have a high correlation with your current balance, right? And that is something that you will observe in this plot. Right now we do not have that. So that's why all the correlation values are valued between, let's say, maximum value you see is 0.17. And all the rest of the values are quite small here, right? And this is what your correlation heat map gives you. Okay. So this is what we have here. Okay, so now you can read this plot to find any interesting ideas that you can figure out. And there are some exercises that we have put in the notebook as well. And as we have shared that you can go through this notebook. Okay, you can go through each of these ideas. You can write down your own ideas and information. And in the exercise, what we have written is you can do a multivariate feature analysis. Okay, and so what is a multivariate feature analysis? Instead of just checking two variables, you check three variables. You pick up two variables and then in a combination, check its information, check its connection, check its relationship with the target variable. That's what you call as the multivariate analysis. Okay, and you can try that here. So there are various ways in which you can use colors and various ways in which, for example, different you can create a box plot of a continuous variable and use different colors for the box plot for a third categorical variable and do that. So there are various ways to EDA. And just to, before I complete the EDA part and hand it over to Nikhil for the model building part, I just want to give you some best practices on the EDA part. Okay, so I'll just add it here itself. So first part is EDA has a structure, but it is also an art. Okay, so if you would have seen me working on this EDA, you saw that I started with the what? I started with univariate analysis, then I did bivariate analysis. I explored all these features. Okay, so it looks like it has a structure, right? You see univariate analysis, bivariate. So whenever I will go on to solve a hackathon, what I will do is I will first do my univariate analysis, I will do my bivariate analysis, and that's it. My EDA is done. No, that's not the way. What you need to do is you need to first understand what is the problem. Okay, and on the basis of univariate analysis, you can change course. Maybe you need to consider relationship between three variables, and that is informed by the problem statement. All right. So while answering some of these questions, so does this variable impact the target? You might encounter new questions. Okay, and on the basis of that, you create your new questions. So hypothesis can also be created in between your problem statement as well. So for example, if you observe something and so you had an assumption about a variable and that does not turn out to be true. That variable had much more categories than you imagined it to be. Okay, so in that case, you might have to do another, might have to ask more questions and answer them with respect to that. So EDA does have a structure, but you have to be creative with it as well. Because if EDA was that simple, everybody would be ending on the top of the leaderboard, right? But EDA has an art to it. With practice, you will understand this art. With practice, you will see and ask the right questions. Okay, it's all about asking the right questions. The rest of it, the Python, R, and everything else is just a tool. Okay, the person or the data science professional who asks the right questions is the one who is able to actually gain something worthwhile while solving all these problems. So EDA has a structure, but it is also an art. Okay, it's a teachable art. Okay, and it's a trainable art, but even in that case, there are so the data science and the machine learning domain is so vast. You'll see a lot of different types of data set where different kind of EDA needs to be done. Let's say you are working on a text data. Okay, there are all words. These are all words. What EDA do you do there? Maybe you create a word cloud. Okay, maybe you create a bag of words and see how many terms are appearing there. Okay, so that's the part of exploratory data analysis. Okay. 2. It's not about how beautiful the plots are. Okay. So it doesn't matter that if you have just used pivot tables, okay, if you have just used pivot tables and you are able to, concretely explain to me what each of these values mean. So pivot tables, if you would have used Excel, you would identify them. They are just, so all these plots, but with just numbers. Even if you're doing that, but that is backed by good questions and good analysis. That is more useful than creating any beautiful plots. Because if you would know about a function called pandas profiling, what it does is it does a univariate and bivariate analysis of all your variables with just one line of code. It's called pandas profiling. So basically all your EDA is done with that. But no, EDA is not just that. Okay, EDA is more about understanding the problem, trying different things, visualizing often what relationship that you want to see, and ultimately it's about answering the questions that you have drafted and some new questions that you come up while answering the previous questions. Okay, now what else? What else? So EDA is the backbone of any ML project for structured data. So just to give you a brief idea of structured versus unstructured data is, let's say you're working on text, working on images, that's unstructured data. Here we are working on structured data. So structured data, whenever you will have variables with interpretation. This is age, this is gender, this is bank balance, and so on. Okay, and using all these informations, you can create features that can improve your machine learning model. So that is why we call it a backbone, because all your feature engineering ideas, all your machine learning model building ideas will end up depending on how well you do the EDA. Yeah, how well you do the EDA. So that's very important. Okay, so EDA essentially is the backbone of your machine learning project or any hackathon as well. Okay, don't just go on and download the data set, build your model and make your submission. Under most circumstances, your hackathon will not be of a few hours. You will have a day or two. The Janta hacks that we have been doing in the past, they have been of the duration of 9 days, sometimes of 2 days as well, but that depends on the problem complexity. But ultimately, you will have enough time to explore the data, first of all, because if you really want to extract the maximum out of these hackathons and not just get a rank on them, you follow all these steps. Okay, even if you don't follow, you still will be able to get a good score on the leaderboard. But then you will not know how to structure and how to solve a machine learning project. That's the ultimate aim, right? Hackathons are means to an end. What is the end? Doing well as a data science professional or getting hired as a data science professional. Okay. So solve these hackathons in a way such that you're able to learn maximum from it. And then you're able to use those learnings in your projects, in your job roles or your interviews. Okay. So these are the 3 most important points that I wanted to highlight about EDA. Okay. So what is next? What is next? Once you have done the EDA, what is next? Now, after EDA, you have to do pre-processing. So if you want to build a machine learning model, you want to do pre-processing because machine learning model cannot read variables such as male, female, strings. It doesn't read that. You have to pre-process them in order to be readable for machine learning models. But even before that, you would create some baseline models. You would say that using a very simple model, let's see what performance that I'm getting. That's what you call as baseline model. Okay. So in order to do that, you create some baseline models. First of all, what is these baseline models? These are very simple models that give you a benchmark of performance. So if your ML model is not able to do any value than your baseline model, then you definitely know your ML model has a bug. You need to resolve that first in order to move forward. Okay. And then once you've created the baseline, then you go on to build your machine learning models. For classification, you go on to do logistic regression. You do decision trees, then ensemble models, which such as random forests. Then you have boosting models. Finally, you decide your cross-validation strategy as well. And then you make submissions to the leaderboard in order to see how well you are doing there. And finally, make your final submission. Okay. So all these things will be covered starting. So all these things will be covered by my colleague, Nikhil. So just to give you a quick recap on his introduction. So he has just joined our data science team as a data scientist. And if you would have been participating in data hacks, he's one of the top performers there. He's ranked 24 on the AV platform at DataHack. He has finished in top 3 in more than 25 hackathons. And I've consistently seen him improve from when he just started out. Okay, and so next I will hand it over to Nikhil to take it forward from here. So today our objective is to not complete the project, but build a simple baseline, make your first submission. So all of you here who are and I'm very delighted by the response that we've got from this. So we all of you who are here, I want each one of you to make your first submission today if you haven't already. Okay, with the baseline that we create with Nikhil. Okay, and this notebook will be shared with you guys. Okay, this video will be shared with you guys to ensure that you are able to follow up, you're able to make that submission and do well. And that's our objective from this entire webinar. And in fact, both these webinars. So this session we discussed some basic things, EDA, and then we were also building. So in the last 1 hour we will be building our baseline model, and with that baseline model we will be making our first submission. In the next one we will be going into much more advanced concepts, building features, doing feature engineering, doing feature selection, trying different models, ultimately even trying ensemble models and making our final submission and improving that. All right. So now I will hand it over to Nikhil, who will now take it up from here, build his baseline model and show it to you guys that how you can create a simple rule-based model to get a very decent performance on this data set. So Nikhil, over to you. I'm stopping my screen share now.
Hello guys. Hello guys. So firstly, I would like to thank Ankit. That was really a wonderful session. In fact, even I learned a thing or two there. So guys, before being such a good competitor in machine learning competitions, even once I was a beginner as you. So it has been around 2 to 3 years that I started participating and doing well in machine learning competitions. So at the beginning, for the first 2 to 3 months, even I struggled. Like I did not know how to make my submission, or once I have seen what the data is, how do I approach the problem? How do I make a baseline submission? And then how do I actually improve from there? So all these questions, I'll try to get it resolved so that you get a proper structured approach. So, okay, when I get a data set, how do I do the EDA? That part has already been explained by Ankit. How do I analyze the data? From analyzing the data to actually making your submission and then improving upon it. So from being a top 100 participant, how can you be a top 10 participant in any machine learning competition? These are the things that I'll be covering today. So let me share my screen with you guys. Okay, yes. I hope you guys can see my screen now.
Yes, Nikhil.
1 second. Okay. Yeah. So, yeah. Before going on into building a baseline model, we should firstly know what a metric is, right? So metric is basically the scoring system that is used to evaluate our submissions. For example, the metric could be accuracy. So everyone knows about accuracy. So if out of 5 of my predictions, 3 of my predictions are correct, then I get an accuracy of 60%. And say if out of 5 of my predictions, all the 5 are correct, then I get an accuracy of 100%. But uh, if we see the data set that we have here, this data set is actually quite imbalanced. So when you talk about imbalanced data sets, in our case specifically, you see that we have 90% of negative examples or the customers who haven't subscribed to a term deposit, and only 10% of the positive examples. So uh, if you take accuracy as the metric and you predict that all customers will not be subscribing to any term deposit, then in that case what will happen is, say you'll easily get a 90% accuracy, right? Because 90% of the times you will be correct. So even without predicting anything or making an ML model, you'll get 90% accuracy. But does that 90% accuracy make sense to you? No, right? Because you actually want to identify the customers that will subscribe to the term deposit, so that it will be beneficiary to your bank. Or even in case of some kind of business, you want to find customers that will likely buy your product, so you can deploy some kind of strategies for retaining those customers or sending out some kind of promotional offers to them, things like that. So here the metric that we have is F1 score. So F1 score is basically the harmonic mean of precision and recall. I guess you guys might already know what precision and recall is. There's actually a wonderful explanation on Wikipedia if you go here. So I have provided the link in the notebook. Yeah. So if you see precision, it's this true positives divided by true positives by false positives. So what is true positive? What is false positive? So basically, if you see this phrase, it has 2 words. So the right part is what a model is predicting, and the left part is the actual value. So if you say this is negative, so our model is predicting these examples as negative, and false. False means these examples are actually negative. So we are doing correct here. Now again, you see this positive. So positive means that our model is predicting this as positive, or in our case, our model is telling us that these are the customers that have subscribed to a term deposit. And if you see the left side, it's true. So true means these customers actually had subscribed to a term deposit. So this is the part that we are getting correct, right? This is the part that we are getting wrong. So again, so precision is true positive divided by true positives by false positives, and recall is true positives divided by true positives, if you see the light green area, and by false negatives. So in both the cases, you see that true positives is there in the numerator. So what happens if the true positives is 0? So when I explain to you, if I predict everything as 0, the true positives will be 0, right? So if we have the true positives as 0, we'll get our F1 score as 0. Okay. So, okay, we will now try to make one simple baseline model. So before trying to make one simple baseline model, we'll make a helper function. So this helper function will actually be useful to us throughout the phase of these 2 webinars. So basically what this helper function will do is, it will firstly we have our predictions in the form of, say, some numpy array or some pandas series. So see, since I'm dealing with Python, I'm explaining in terms of, say, numpy or pandas. In case of R, you might have something different, or if you're using Java, so that doesn't matter. uh, for the Python part I'm explaining, so if you see, SS is basically the sample submission. So I guess we had read the sample submission earlier. So sample submissions target column. So target column is a variable which is uh, uh, containing the value term deposit subscribed. So when I have put my arrow here, you can actually see it's term deposit subscribed. So this function will be actually accepting 2 arguments. First will be my predictions, and second is the file name that I want to save my predictions with. So for the
Hey, Nikhil,
platform analysis, yeah, yeah,
request you to zoom in a bit. Zoom in a
sure,
bit.
sure,
Yeah,
sure.
thank you.
Okay, yeah. 1 second.
Perfect. Yeah.
Yeah, 1 second. Yeah. So yeah, if you see my function is having actually 2 parameters. First is the predictions, and second is the file name that I want to save my predictions with. So basically, for the HackLive platform, you need to submit your predictions as a CSV, as Ankit had already mentioned. So first thing we'll do is we'll set that sample submissions target column to the predictions. And this, okay, so one thing, yeah. If you see the sample submission once again, I guess it will be a bit helpful. Yeah. So the sample submission contains two columns. First is the identifier column and second is the target column. So this target column, instead of having all zeros, we are setting it to our prediction. So what our model is predicting. Then we will save it to the file name that we have provided. And then this part is useful for downloading it from Google Colab. So Google Colab is actually a cloud platform. We are working on cloud. So we need to download it to our local machine. So for that, we'll use these two lines. So from google.colab import files. So files is a module that's imported, and then from that module, we are calling the download function. Okay. So first we will be going with the case that we had discussed earlier. We'll predict all instances as majority. So as we saw before too, the 0 was a majority class. So we have around say 30,000 or say 28,000 instances of zeros. So what we'll do is we'll make an array, numpy array, which has all zeros with length of the training data set. So we want to check what will be the F1 score if we predict all zeros for the training data set. Since we have the target for the training data set, we can actually check our score in the training data set here itself, right? So if we do this, predictions target is numpy.zeros length train, we can actually, yeah, one second. Okay, I guess I need to run my things again. Just one second. I have to run my, these things are already there. Just give me a minute. Once it runs completely, I guess these cells are not executed in my machine, so it's causing some problem. So yes, one second. Yes, we were here. Yeah, we were in this. Yeah. Oh, I had missed this cell. So this cell is actually defining our target. So target is trains target column, and then we were seeing targets value count. So once this runs, yeah, now this will work. Yeah. So if you see the accuracy score, it's 90% or 0.9, and the F1 score is 0. So had the metric been accuracy, we would always we would have obviously got an accuracy of 90%. But F1 score here is telling us that we need to create a better model than simply predicting all instances as majority. Okay. Okay. Yeah. So you can actually go and submit this. Okay, so I'll write one simple code to submit this. So if you see, yeah, predictions for test set, we can do the same thing, right? So in case of, instead of threads target, we can do threads test. So this will basically make an array with filled with all zeros for the test set, and then we can actually submit it and see in the leaderboard. So we are actually getting an F1 score of 0. So we can name it as a HackLive 0 sub. Makes sense. So yeah, let's do it. Okay. Yeah. So once we have got this, we can go here. So if you see this part, I have gone to the solution checker of the analytics Vidya platform, and then you scroll down, and then you can click here. So if you click on the solution file, you can actually upload the solution file. So you go to downloads. So HackLive 0 submission. Okay, so you can name it as a baseline 0 model. And let's see our score here. Perfect. Our score is 0 as expected. So let's go back to our EDA notebook. Now we'll do something else. So how do we improve upon this submission? The second thing we can do is we can randomly predict any submission to be 0 or 1. So when we talk about randomness, there's one big issue with randomness is that randomness cannot be reproduced. For example, say if I want to generate three numbers between 1 to 10, first time I could get something as 5, 2, and 7. Next time I could get something as 1, 4, and 6. A third time I could get it as something else. But for my data science experiments, I always want the things to be reproducible. So what I am getting here on the notebook, when you guys actually go to your homes and try the same notebook, you should all be getting the same results. So for this, what we do is we set the seed. So np.random.seed function, it actually helps us set the seed. So basically this randomness will be reproduced again when you run the notebook, right? So next thing what we are going to do is we are predicting uh, all the samples to be either 0 or 1, right? So this Pretz target is equal to uh, uh, so we are predicting all samples to be either 0 or 1. So the Pretz target is np.random.choice between these uh, two numbers. So these two numbers are passed as a list. So 0 and 1. So from 0 and 1 will be taking either one of the numbers, and what will be the size of our predictions? It will be the length of the training data set. So we can actually check the F1 score. And if we run this, yeah, so we are getting the same F1 score. So 1.767. Now see, if you change the random seed here, so if you change it to say 4, you got a different uh, F1 score. So again, it was earlier it was 0.176, but now it's 0.175. You can try it with some other random number, say 47. Okay. So yeah, it changes a bit. We'll keep it to 2. Yeah. Now we can actually go and submit this. So this got 0.1767 for a training data set. So what will be the score of this model for a leaderboard? So let's see. Okay, yeah. So for the test predictions to have done the same thing. So yeah, np.random.choice between 0 and 1. This time the size will be the length of the test data set because we are predicting on the test data set. And the name I have given is HackLive random sub. So again, let's go and submit this. Okay. So downloads HackLive random sub. Okay. So random submission. Okay. So 0.189. So this is actually much better score than our previous submission. So for all your submissions, if you want to see your scores, you can go to my submissions tab and you can actually see the scores here. So 0.19 is actually close to our training score of 0.17. So this is actually a very important concept in machine learning hackathon, especially that what you're getting in your validation scores and what you're getting in the leaderboard, they must align. So for now, we haven't created a validation set. The validation part will be covered later on, but for any machine learning hackathon, you must always see that what you're getting on the leaderboard and what you're getting locally, they must match so that you don't end up overfitting. So what happens when you overfit is in the public leaderboard, say you are having a rank of say 5 or a rank of 10, and in the private leaderboard that rank drops to 40 or 50, because what you're doing essentially is you're only predicting the public test part nicely or much more accurately compared to the private test part. So again, the validation strategy and how to choose your final submission will be discussed later on. Okay. Okay. Now, many of you guys were asking, so now we have done EDA. So what's the usefulness of this EDA? So how do we use EDA to actually create some kinds of features? Is EDA even helpful? So EDA is definitely helpful in knowing your data, understanding your data. So unless you understand your data, you can't really go ahead with it. You might make some model, make some predictions, but that predictions won't make sense to you and obviously not make you a top ranker in any machine learning competition. So yeah, Now we'll go with rule-based classifier. So what is rule-based classifier? So if I give you a simple example, anyone with the age of over 60, we'll call him as old, and anyone with the age of say less than 15, we'll call him as a child, and anyone with the age say between 15 to 60, we'll call him as a young person. So this is a rule. So the first rule says that age less than 15 should be classified as a child. Age between, second rule says that age between 15 to 60 should be classified as a young person, and more than 60 should be classified as an old person, right? Now, in our earlier EDA, Ankit had explained to you that Ankit had identified two important features. So if you see the EDA, we can see that the balance and the last contact duration, in the balance and the last contact duration, there's actually quite a difference between the people who subscribed and the people who did not subscribe. So why are we taking median again? Because we are dealing with features which have a lot of outliers. So even balance and last contact duration both had a lot of outliers. Now if you see the median balance for people who actually subscribed to our term deposit, the median balance was around 800, and for the people who did not subscribe to a term deposit, the median balance was around 400. So that's quite a gap of around say 400. And if you see the median last contact duration for the people who actually subscribe to the term deposit, uh, it was around 450. Yeah. And the people who did not subscribe to the term deposit, it was around say 150, 160 something, right? So from these two features, can we guys actually, yeah, yeah. So from these two features, can we guys actually think of some uh, way to make a rule so that we can classify our data set, right? So one thing that's very obvious to me here is if the median balance for the people who did not subscribe to a term deposit was 400, any any person who's having a balance less than 400, most probably he would not have subscribed uh, to a term deposit. And similarly, if you see the last contact duration too, if the median last contact duration for the people who did not subscribe to a term deposit, it was around say 160. So the people who had the who had a last contact duration less than 160, they probably did not subscribe to a term deposit. So just to reiterate the last contact duration feature, it's basically the length of the call made to the customer. So say say I am a person who is contacting a customer. So if I have spent say more minutes or more seconds talking with him, probably I have persuaded him into buying my term deposit subscribed. So yeah, one thing that I would add on here is if you get an intuition of the data, if you understand the data, you can actually solve the problem really well. So again, I'm understanding the data here that okay, if I have made a long contact with the customer, then probably I have persuaded him into buying my term deposit subscribe. And again, we can validate our hypothesis using EDA or statistical tests. So yeah, this we can see here. So we'll make a simple rule classifier. So we'll make a very simple function for this. So this rule-based classifier is a function which accepts a data frame as a parameter. Okay. So when it accepts the data frame as a parameter, firstly, we'll assume that all customers have subscribed to a term deposit. So np.once makes an one-dimensional array with size equal to the length of the data frame that's provided. So we'll be passing both the training data frame and the test data frame here. And then we'll this filter is nothing but the rule. So instead of filter, you can name it as rule. So you people understand it better. Okay. So I had discussed about two rules earlier. First is if the last contact duration is say less than 150, or you can put it as 160. And if the balance is less than 400, the predictions that are following the rule. So this is basically an OR operator. So only the samples which will be so all the samples which will be following either this rule or this rule, for all those samples we are telling that okay, this customer has probably not subscribed to my term deposit. And then once I'm done, I'll be returning my predictions. Okay, so let's see. Yeah, for the training data set, we are getting an F1 score of 0.3. So this is actually much better than a random submission. So a random submission got only 0.17 or 0.18. So I'm glad that we are actually improving. So yeah, what we can do is we can submit this rule-based classifier to the leaderboard and see what's the score. Okay. Yeah. So once this is done, we go to the solution file. Okay. Yeah, rule-based. Okay, so base simple classifier or something. Okay, so let's see the score. Wow, this score is actually very close to the score that we got it for the training data set. Excuse me. So both training data set and the test data set, at least the public part of the test data set, are getting similar scores. So yeah. Okay. Yeah, 1 second. Yeah. Now we can actually go ahead and change the rules. So something like instead of the last contact duration uh, being 150, we could try to tinker around with it, and we'd say I'll keep last contact duration as less than 100, or say I'll keep, okay, let's try with changing one rule first and seeing how does the F1 score gets affected. See, F1 score reduced. So again, you can again try submitting it on the leaderboard and seeing, okay, so we'll actually try and submit it on the leaderboard and see what this gets on the leaderboard. Okay, so we'll do this too. Okay, rule based 2. Yeah. So rule based 2. Okay, so yeah, let's see. Again, this was very close to what I got for the training data set. So this actually is a good sign. But again, if it happened for the validation set, I would actually say that my leaderboard and validation are synced. So I'm progressing in the right direction. That will be discussed later on. Okay, 1 second. Yeah. So once, yeah, since this is done, so what I would recommend you guys is once you get this notebook, so many of you guys were asking when we'll get the notebook. So you'll get the notebook emailed to your registered email address. So the email address with which you have registered for the hackathon, you'll get it emailed right there. So you don't need to worry about how will I get the email address or how will I access the videos of the webinars if I miss something. So don't need to worry about it. And what I would recommend you guys is after you have got the notebook, you actually try different rules and see how do these perform. For example, instead of 100, I put again it as say 200. If I put it as 200, is my F1 score increasing or decreasing? See, my F1 score increased to 0.33. Now again, I'll not be submitting it to the leaderboard, but you are most welcome to try. So you can actually tinker around with the data, play around with the data and see what kind of F1 score, what kind of metric uh, I'm getting here. So is my metric improving? Is my metric not improving? But the basic idea of a rule-based classifier is without using any kind of machine learning model, without using any kind of complex what you call neural networks or deep learning architectures or gradient boosting or things like that, we are getting a decent F1 score. You can actually get a much better F1 score if you try to add more rules or more variables. Here, out of 16 to 17 variables, I have used just 2 variables and a very simple condition. You can actually try with more variables and see. And then you might actually get a F1 score of say 0.4, 0.5. We don't know, right? Okay. So yeah, I guess this part is done. Yeah. So yeah, one thing I'd like to add about rule-based classifier is rule-based classifier is very similar to how a decision tree works. So again, we'll not be explaining any algorithm here. So here we are just here to share the approach, the way you are uh, approaching the problem, the way you should actually be approaching the problem, the way you should do the analysis and things like that. So if you want to learn about the algorithms, I have posted the links in tomorrow's notebook too, so you can go to actually analytics Vidya's courses itself and read more about the algorithm if you are a beginner. And if you already know about the decision tree and how it works, or see any algorithm, it's well and good. Okay, so I guess I have not seen the QA section for a long time, so let's have a look at the QA session. Okay, so yeah, how to know which random seed to choose. So you don't need to know actually which random seed to choose, but you need to fix a random seed so that when others are using your notebook, or when others are actually running your code, they get the same results as you are getting. So that's the basically the utility of a random seed. So you can make it as 42. Most people make the random seed as 42. I'm not sure what's with that magical number, but yeah, most people keep the random seed as 42. So you can keep it as, say, your date of birth or anything. That doesn't matter, but it's important that you keep a random seed, right? Yeah. So you have one more question. So we want a machine learning model to learn from data then rather than making it rule based. So if you see here, we have actually learned from the data through analyzing and EDA. We have learned from the data, and we are applying our learning on the data to make a rule based classify, right? So yeah, talking about machine learning models, that will be covered later. So if you talk about tomorrow's agenda, we'll be starting from very simple machine learning models, and we'll go to ensemblings. So I'll actually show you how to go from top 100, top 200 to the top 10 participants. So you don't worry about that. Okay. uh, Talking about using results and learning from rule based classifier later in the model improvement process, you actually don't need it here, but you can see, if you are already familiar with classifiers, you can actually make some features. So you can make features as, say, the median bank balance, or the median bank balance for, or say, what we had, the last contact duration. You can try removing outliers. We'll be using it, but how we'll be using it, that will be the agenda for tomorrow. But the exact results from the rule based classifier later in the model improvement process. One thing, if you have heard about ensembling, is you can actually use these results in ensembling. But for ensembling, again, you will need to have some kind of proper validation set and things like that. So that will be covered later. Okay, since our target variable is not balanced, why did not we use log? So log transformation is used for numerical variables. So numerical variables are basically the features that you have. You do not apply any kind of transformation on the target because you want to learn the target, right? And if you talk about log transformation, that happens when you are dealing with, say, regression problems. So when you say, when I want to predict the amount of sales that I'll be having for, say, one particular store, so in that case you'll be using some kinds of log transformation, but then again it depends on the metric. For classification, usually you do not change the target. The target is as it is. You can play with the features and see how the target improves. Okay, we can make as many rules as we want and get an F1 score as 100, right? Yeah, you can make it, but that F1 score of 100, it could just be 100 on the training data set. You can't be sure that my F100 that I'm getting on the training data set, that same F1 score I'm getting on the test data set or not. For that, you can obviously use the leaderboard to validate or create one validation set. Okay. Yeah. Do we have to submit the code today? If so, well, I guess I have shown you this. So basically, you go to the HackLive platform. Yeah. Okay. Yeah. Once. Sorry. Yeah. So basically, you go to the HackLive platform and then you start the video. You make the submission. So if you see the HackLive platform, okay, I'll show you this. Okay, you go here, you go to the solution checker. Yeah, when you go to the solution checker, you get an option to upload your file. This file is basically the CSV file that you have created. So I'd shown you a function to create a CSV file, get your predictions in the CSV file, and then you can add a comment and submit it. Okay. Okay, so yeah, let's see more questions. Okay. this filter conditions will be used again in algorithm and model building. So yeah, it depends upon you, the kind of features that you're creating, that filter, you can use filter conditions. But if you're using tree based models, so tree based models will actually find optimal splits or optimal filters or to be used in the case of model building. So again, it depends on the type of algorithm you're using. For example, if you're using things like logistic regression, you might want to add filters. Okay, you can submit anytime during these 2 days. So this hackathon will be open till Sunday midnight, so you don't need to worry. So is F1 score that important? So if you talk about the metric plays a very important role, because we want a metric to align with our business objectives. So here F1 score is important because we want to identify customers that have actually subscribed to a term deposit, right? So again, it depends on your business objective. So F1 score is the right metric or the good metric here, but again, in some other case of problem, we could have some other metric important. Okay, how rule based modeling is different from ML modeling. So rule based machine learning models, you have some kinds of explicit algorithms which try to learn from the data, and rule based modeling is basically what we are observing from the data and we have created a simple rule. So even you can roughly call decision a simple decision tree as a rule based model too, because again it's creating some kind of rules, but that's for intuition. Okay, there are a lot of questions. Okay, is it necessary to have variable distribution as well as bell curve for better accuracy? So okay, I guess you want to say about normal distribution. So normal distributions are important in, say, logistic regression or neural networks. So in that case, if you have variables which have normal distributions, then it will actually help your model. But in case of decision trees, you don't even need to scale the data. So no scaling is required, no normal distributions is required. Okay, yes, you can use any model you want, you can use any model, any programming language you want, just that it is open source. And if you finish in the top positions, you can reproduce your model. So you can use Java, Python, R, any notebook, or if you want to use Spider, any text editor, there's no issue with that. Okay, so if we do upsampling, then F1 score may increase. So yeah, upsampling is a technique, but again, F1 score may increase or not increase, that you have to try. It depends on the kind of sampling strategy that you are following. Okay. Yeah. When will we lose information while when changing continuous variables to categorical variables, say based on EDA? When to do it, when not to do it. Okay, so that part could be covered tomorrow. It's not the agenda of today, but yes, obviously you lose some information, right? So you had, for giving a simple example, you had customers with the age ranging from say 10 to 100, and then you have bend it into say child, child, young, and adult. So you only have three categories. You actually don't know the individual age of a customer, so that could be helpful to your model. So yeah, you use some kind of information, that's for sure. Yeah, oversampling could improve F1 score, but I have one other technique that I'll show you tomorrow. That actually, that's basically a trick or hack you use to improve your F1 score. So that's for tomorrow. Yeah.
Yeah, so
Yes.
machine learning related questions and everything we will try to cover tomorrow. So right now this Q&A duration, try to ask questions that are related to this session so that it is more useful for everyone present. So I'll also answer a couple of questions.
Sure, sure, Ankit.
So yeah. So one question was related to EDA. So it says that here we just have 10 to 15 features. What if we have 30, 40 features, or let's say 300, 400 features? What do we do in that case? Well, the short answer is you do the same. Okay. You might feel that with 300, 400 variables, you would be making a lot of plots. But if there are 300, 400 variables, I'm 100% sure that there are groups between them. So let's say it is related to, some of the variables might be related to balances. Some of the variables might be related to customer demographics. Does the person live in urban area, rural area, and so on? Then some of the variables might be related to his last credit card statement. So you can club these variables into various blocks or categories or groups. And within each group, then it will be a a set of 17, 18 variables. Okay, you can combine some of these variables to get new features and then explore them. So for example, if you have three kinds of expenses as your variables, you can combine all these expenses to create a total expenses uh, variable, then observe that. Okay, so even if you have a large number of variables, so you can do various things. So for example, you can check correlation. If your target has a very low if your target variable, if they're not very useful with the target variable, then you might not need to explore them further. Sometimes you would not want to create a group of variables that are very similar to each other and then explore them together. So then essentially breaking down your larger problem into smaller problems and then solving them individually. That's the way to do it when you have large number of variables. Okay. Yeah, I see. We can
Yeah,
make as
actually.
many rules. Yeah. Yeah, you're free to answer, Nikhil, if you see any questions.
Sure, sure, sure.
Hmm.
So, okay, yeah, this question was already answered by Ankit. There are a lot of questions, so I'll be trying to answer most of them, but I might skip some which I find irrelevant to the agenda of this sessions. Okay.
Hmm. Hmm.
So if we use bins for continuous features, then we should keep the continuous feature column. So again, that's the modeling part. So you can keep both and you can keep either one of them, but that again will deal later. So what is oversampling? So yeah, just to give a brief idea, oversampling is increasing either the minority class or the majority class. In this case, we had say only 10% of the samples. We could use some way to generate artificial data and make this 10% to 20%. Okay. Please help me understand the submission file once again from the solution checker. So
Yeah, let's
the
repeat that, Nikhil, for a bit.
yeah,
Yeah.
okay, sure. So does distribution of features affect the ML model? So yes. So if the feature is skewed, so I'd say if the feature is not normally distributed, it might affect the logistic regression or neural network model. So just to answer your question in short, yes, it affects. Okay. What can be the max value of F1 score? F1 score can have a max value of 1. Okay. Okay. Can you talk again about rule-based classifier? So rule-based classifier is basically we create some kind of rules to classify our samples. So like I gave an example, or Ankit had already talked about it in his EDA. People more than age of 60 are old and people less than age of 60 are not old. So we can use this rule to classify people as being old or not old. Okay. There are various ways to treat outliers. Is there any particular rule that we use? Again, that's agenda for tomorrow. But yeah, there's no particular hard and fast rule. It depends on the kind of data, whether outliers are significant for your analysis or not. Okay. Do we need to balance the imbalanced target data? If so, what's the best technique? So yes, I'll be talking about it in tomorrow's session. So don't worry about it. Please repeat what we need to submit. Okay. Can you explain which steps come first? Ankit, you want to take this question? Hello. Yeah, okay.
What is the question? What is the
Yeah.
question?
Can you explain which steps come first? Clean data followed by EDA or EDA and
Ah,
then clean data? Yeah.
yeah, yeah. Okay. So the first step is understanding the problem statement or the problem definition. The second step is hypothesis generation, where you list down the questions that you want to answer from your EDA. The third step is the exploratory data analysis that you do, which is visualizations and exploring the data for insights. Next step, so again, within EDA, there could be some data cleaning processes involved. So for example, if there is noise in the data, if there are some spelling mistakes in the categories, you would want to correct that. So that's data cleaning, right? You want to maybe group the data and then see it. Okay, so data cleaning and data manipulation is inbuilt in EDA itself. Okay, and as I'm saying this, there is you are often you often do data manipulation within EDA. You do data manipulation after EDA as well when you are in the data pre-processing step, where you pre-process your data. Let's say you fill in your missing values, impute your missing values, and you that's data cleaning, right? So you remove the missing values, you remove the outliers, and you convert your categorical variables into numbers so as to take them as input into your machine learning model. Then finally build your model, make predictions after creating your validation strategy. So
Okay,
that's
yeah.
basically, those are basically the steps for your machine learning. So I think some of them have questions related to how do we submit, and Nikhil, it would be a good idea to just repeat that part once more, wherein you
Sure,
created
sure,
that
sure.
submission, downloaded it, and uploaded it on the platform. Also show them the leaderboard so that they can clearly see where is it reflecting.
Okay, sure, sure, Ankit. I'll do that. So, okay, yeah. Yeah, I had this function. So before this function, I had shown you the sample submission. So this is the format in which you need to submit the submissions onto the leaderboard. So this will have two columns. First is the identifier column and second is the target column. So in our case, the target column is Tom deposit subscribed, right? Now then I had created a very simple function which accepts your test predictions and the file name in which by which you want to download the submissions. So the first thing you will do is you'll set your sample submissions target column to the predictions. The second thing is we'll save these predictions to a CSV format because Analytics Vidya's data hack platform wants you to send the submission as a CSV format file. Okay. And the third step is basically to download this file. So you won't be needing this third step if you're doing it on a local machine. So you already have the file saved to your local directory. So since I'm working on Google Colab, I'm saving the file and then I'm downloading the file. Okay. Now, once I have downloaded the file, so okay, let me run once. Okay. I'll run this again. HackLive 0 submission. And now see my file is downloading. Once I've created the predictions, then I'm downloading the file. I've called a function which I had shown you earlier. So next what I'll do is go to this HackLive platform. Now in this HackLive, you'll see there are multiple tabs. So about, then problem statement, then solution checker. So we are concerned with solution checker. So once we click on solution checker, we are automatically scrolled. Uh, we automatically get the solution checker part where we can actually submit a solution. So there are two things regarding this. First is the code files. Second is the solution file. So you can add the code file later or when you are setting your final submission. So that I'll show you later. But for the solution file, you click on the upload file, then you go, it's stored in my downloads folder. So I'm going to downloads. So then I'll click on the file which I want to submit. I click on open. So yeah, I can see my file name is being reflected here. So then I add some description which can help me identify which is the submission, right? So HackLive 0 submission trial, something like this. And then when I click on add solution, my solution starts getting uploaded. Once it gets uploaded, I can see my score. Now you can actually go and see the leaderboard. So if you see the leaderboard, you can see people have actually already submitted, and these people have got an F1 score of say 0.66, 0.63, or say 0.57. So these are the top three performers now. So one of your assignments would actually be to go and submit on the leaderboard and try to get in the top 3 or top 10 of the people. So this is basically my submission. It's pretty low, 7, but yeah, nevertheless. Okay.
So right now we are just at baseline. Tomorrow we will
Yeah.
of course improve this model to a much better
Hmm.
score
Yeah.
at par with what we are seeing at the top scores as well. So what you see as top scores, don't get intimidated by that. These are people who are, like Nikhil, have been participating in a lot of hackathons, and they have, you know, built a few tricks and tips of their own, which of course Nikhil will also reveal in the next class or the next webinar. And the overall idea is to not really just get to the top of it, but really understand the problem and the process behind solving a data science problem rather than just asking the right questions. Oh, how do I clean the data? How do I detect outliers? How do I pre-process the data in order to fit a model? So these are the questions you should ask, not how do I, you know, top the leaderboard. Okay, don't be driven by the outcome, but be driven by the process it takes to reach to the top of the hackathons. Okay, so you start at the bottom, but with time you will improve, and this is where the next session will come into the picture, which is at the same time, 12 noon. and it will start at the same time and also end around the same time as well. So for today, this notebook and the video will be shared with you guys. You can download the notebook, run it on your own, and make your first submission. So it could be the same score, but do make your first submission to know how the platform works. How do you do that? And if you have any questions, so can you show the discuss tab, Nikhil?
Okay, yeah, discuss tab. So 1 second. So if
Yes.
you have any questions, you can actually go to the 1 second. Yeah, yeah. You can go to the discuss tab and post your questions, right? So two people have already posted their questions, right? So if you want to post your own question, you can click on post. 1 second. Okay, yeah. You can firstly give a description. So okay, something like, what is the best way to do feature selection, something like this. And then you can write some description like, I have tried these techniques, something like that, these techniques, something like this. And then you can click on post. Once you click on post, your thing is reflected in the discussion form. So if you want to actually answer the queries raised by other users, you can go and click on this, and then you'll 1 second, yeah, you'll see their question. So this is my first time. I was wondering, what do I need to install Zoom on my machine or something like this. Then you can click to comment, and then you can add your own answer to the question. So you can post questions, you can answer other users questions. So discussions tab is helpful, yeah.
Mhm. Mm. So as Nikhil will also, confirm that using the discussion forum for ideas and feature engineering is a big part of doing well in hackathons. Okay. Only after, so sometimes you might not observe the best features, and sometimes with discussions from other hackers and with, looking at these community posts and forums and ideas and codes, you get new information from it, and then you can use that to your advantage, improving your model much further and making that submission.
Yes. So do we have time for more questions, or should we wrap it up?
Yep. Yeah, I think we can take a couple of more questions and then
Sure,
we
sure.
will wrap up.
Okay. Okay, so ensemble modeling, I'll be covering it later. So Tanmay has a question. We have a skew data like balance. Is it necessary to convert into normal distribution? So you you need to convert it into normal distribution for some of the machine learning models, but again, it will be a discussion for tomorrow. Okay, so you can use recall. See, it again depends on the business objective that you have. So you can use recall. You can use some other metrics such as say AUC also. But again, you need to ensure that your business objective and your metrics align. So it's not why I have not chosen recall, why I have chosen F1, or why I have not chosen some other metric, say log loss. So it depends on your business objective. Okay, so why does the submission file need to have headers? Yes, the submission file needs to have headers. First header is ID, and second is your target column. So the target column in this case is term deposit subscribe. So, okay, if the data set has missing values, how do we deal with them? You can impute it by some value. I'll be talking about it later tomorrow. So you can have something such as mean, median, or you can drop the uh, row itself. So I'll be talking about it later. So can we pre-process the data for rule-based classifiers? See, pre-processing the data, say if you scale the data, so what you got in your EDA, that will not make much sense, right? So if you scale a balance of 400 to a range of 0 to 1, then again you need to do an ED again and see what is that value of 400 in my new range of say 0 to 1. So for rule-based classifiers, at least for what we have done now, it's not necessary to pre-process the data or say do label encoding. Label encoding will change the meaning of the values. For example, instead of a married and single person, I'm getting something as 0 or 1. So for the EDA part, especially, it's recommended not to do any kind of label encoding or changing the values. But imputing missing values is a part of say data cleaning. You might do it, you might not do it. So again, it depends. So, but before imputing missing values, you actually want to have a look at how many missing values are there. So it's useful to impute them or not, things like that. Apply
So many
features.
people have
Yeah.
questions regarding the structure of the hackathon. So this is again, this is a bit different from the regular hackathons that we do. However, the structure remains the same. There is a start date to the hackathon. It started at 12 p.m. IST today, Indian Standard Time, and it will end tomorrow midnight Indian Standard Time. So it's a 1.5 day hackathon. So 36-hour hackathon. This is, and we will do 2 sessions. And first session was just today. For the recordings and the notebooks that will be shared with you guys over the email, and the uh, link for the download link for the recording will also be, you know, shared on the HackLive page. So in the about section, we will update it once we have rendered the video, and we will be able to share it with you today itself. And the notebook will also be shared over the email, and from there you can download the notebook and check the video once more, go back to it to revise and all that. Okay, so that's the structure. So regarding the submissions, it's not necessary that you make a submission today itself, but it will be good if you are able to, understand what we have covered. So if you have covered that part, you can make your first submission, and that will make you ready for the next session. And in the next session, then you can go on to, build your first machine learning model, and later on learn from Nikhil how to improve that further. So yeah, so the learning objectives of this session was, first of all, understand the hackathon platform. What are the elements of the hackathon? How do you make a submission? How to do an EDA? Then how do you create rules? How do you create a baseline for your model, which is using rule-based classifiers? And ultimately make your first submission. Okay, so this was all about understanding the problem and the data set involved in the hackathon process. And for the further details, for such as building your model, how to improve it, climbing the leaderboard, all that will be covered in the next session, which is tomorrow. So this is the time for you to go through the EDA yourself. Okay, this is the time for you to understand the problem, work on the hackathon, give it some time during the evening and tomorrow morning. And before the next session, you are already ready with some of the questions that you would maybe want to get answered in the next session. So the session again will have a very similar structure. We will go through a notebook that will essentially solve this problem, make our predictions, and finally we will improve our model and make our final submission. At the end of it, there will be a 20-25 minute Q&A session that we will do, and try to answer as many questions as we can with this session. So as the objective clearly remains that we want more and more people to participate in these hackathons, because both of us started our career in data science using these hackathons, and we believe that these are, if used wisely, and if participated, if taken seriously, these hackathons can really propel you to better your resume, better your profile, and get to move in a data science role if you're not already. And even if you are in a data science role, there is so much to learn with different kinds of data sets and problem statements. So you should definitely try your hand at some of these and get more experience, get more equipped with different techniques and details with the discussions that happens on the discussion forum at the community and so on. All right, so with this, we will call it a close for today's session. And uh, thank you, Nikhil, for adding the excellent bits on the baseline along with the EDA. And thank you, everyone. It was very nice to see such enthusiasm, and really felt great to answer so many of those questions that you guys asked. And even if I am able to, get uh, 100 people started on their first hackathon, that's a big win for me and Analytics Vidya. And I really wish all of you very good luck in whatever you're pursuing right now, be it a new job in data science, be it improving your skills, and maybe getting a certification, maybe doing well in a hackathon, landing in the top 10 of a leaderboard. Anything that you're attempting to do, I wish you a very good luck in that. And I'll see you tomorrow, same time, 12 p.m. IST, 3-hour session, and we will continue this. Nikhil, any last words?
Yeah, thank you, Ankit, very much for this session and giving me an opportunity to interact with the people in whose position I had been earlier on. So, like, it was a really great session interacting with you, answering some of your questions. And I guess tomorrow will be a much more interesting session. We will actually get to see how to climb the leaderboard. So, I suggest you should not miss tomorrow's session at any cost. Until then, use the wonderful notebook that Ankit has shared. Try to go through the EDA and try to improve your scores. Okay.
So not shared yet, Nikhil, but yes,
Okay.
I
Yeah.
will share the link on the discussion forum as well. I will also send it over email, so you will get your notebook. So don't worry about that. Okay, just focus on what we are covering in the session, and the notebooks, videos. That's our job. We'll take care of that. You will get access to that. All right.
Okay, guys.
Thank you everyone. Bye bye.